Sebentar.
Assalamualaikum, Bu Retno.
Assalamualaikum.
Assalamualaikum,
Assalamualaikum
Dr.
semua.
Nilam. Waalaikumsalam. Terima kasih, Dr. Nilam.
Sama-sama.
kabarnya?
Suara saya jelas ke?
Bagaimana?
Suara saya clear?
Iya, terdengar. Dr.
Alright.
Yeah,
Okay.
we can hear your voice.
Alright, thank you. Apa khabar semua?
Alhamdulillah. Baik, Dr.
Ramai sungguh ni. Ini semua student ke, Bu?
Iya, student Informatics.
Oh,
Yeah. This is from fifth semester. Yes, fifth semester in Department of Informatics.
which semester?
Fifth
Oh, 5th semester.
semester.
Wah, ramai banget ni. So, how many departments in Andi?
In Faculty of Science and Mathematics, we have about seven. It's right, Seven. Seven
7
departments.
departments.
Six
6
department.
departments.
Six
Wow.
department. Yes.
Wow, that's very good. So all of the 6 departments are what we call it technology. Include all the technology.
No, there are some department related to science, like Department of Physics, Department of Chemistry, Department of Biology, and also Department of Mathematics, Department of Statistics.
Oh, it's combination lah, multidiscipline lah, it means.
Yes,
Alright.
science and mathematics.
Okay.
Yes.
Assalamualaikum. Can we start now?
Alright, can?
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Warahmatullahi wabarakatuh.
Distinguished guests, ladies and gentlemen, good morning to all of us and welcome to the first session of Visiting Lecture 2022. To the honorable mention, the Dean of Faculty of Science and Mathematics, Professor Dr. Widowati MSI, and Head of Informatics Department, Dr. Aris Puji Widodo SSI MT, and our keynote speaker, Dr. Nilam Nur Amir Sjarif from Universiti Teknologi Malaysia, and Miss Clara Vania Ph.D. from Amazon Alexa UK, and to the other honorable invited guests. My name is Muhammad Vicky Iksan, and I'm very honored to be here as the Master of Ceremony on today's event. First of all, let us thank God who has given us mercy, happiness, health, and mercy so that we can participate in this special event without any obstacle. And also, I would like to announce some housekeeping notes for today's event. First, we would like to have your cooperation to mute your microphone in order to avoid any interruption in this event. Second, we would like to have your cooperation to use the virtual background that provided in the meeting chat and also to fill the intended form. And the third, feel free to ask our community members via meeting chat if you need any assistance. Distinguished guests, ladies and gentlemen, to start today's event, I would like to call upon the head of Informatics Department, Diponegoro University, Dr. Aris Puji Widodo SSI MT, to give the first welcome speech for this event. Without further ado, Dr. Aris Puji Widodo SSI MT is now pleased to come to the stage. The time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Honorable Dean Faculty, Science and Mathematics, Diponegoro University, with representative Panji Trihasa Ph.D., Honorable invited speaker, Dr. Nilam Nur Amir Sjarif from Universiti Teknologi Malaysia, and Clara Vania Ph.D. from Amazon UK. And all lecturer and all students. First of all, let us thanks to Allah Subhanahu wa Ta'ala, the most gracious and merciful God, because with His permission, today we can gather here to join together for the online visiting professor event in data science and natural language processing. On behalf of Department Informatics, Faculty Science and Mathematics, Diponegoro University, I have the great pleasure to welcome you all the visiting professor event. I'm very happy to welcome most especially the invited speaker. We want to certainly thank you for honoring our invitation in spite your very busy and tight schedule. I want to use this opportunity to congratulate the organization team, lecturer, and also student for the foresight in choosing the best speaker and the topic that has national relevance. Today's seminar topic is data science and natural language processing. Understanding data science field is very important as defined by today industry professional. Data science are one of the most sought after role in corporate today because organization armed with the right talent can derive more value from its data. Moreover, one most important data in data analytics is tech, so understanding what is advancing method or algorithm to process the text using NLP very essential. I hope we could get new insight and more understanding about this field, especially new knowledge for our lecturer and students. Once again, I want to heartily welcome you this event. It is my pleasure one more time to say thank you and will come in visiting professor even Informatics Department, Faculty Science and Mathematics, Diponegoro University. Hopefully what we are doing today is useful for our progress in so thank you very much. Amin. Ya Rabbal Alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Aris Puji Widodo SSIMT. And last but not least, we are very proud today to have the representative of the Dean of Faculty of Science and Mathematics, Diponegoro University, Dr. Panji Triatyaksa, to give an opening speech and officially open this event. Ladies and gentlemen, please join me in welcoming Dr. Panji Triatyaksa. Time is yours.
Dr. Nilam Sjarif from Universiti of Malaysia, and Dr. Clara.
Excuse me, sir. I think you forgot to unmute your microphone.
It's already open, is it? Can you hear my sound?
It's not too clear. Can you bring up the volume a little bit, sir?
Hello.
Okay, sir. You can go. Thank you. Excuse me, sir. It's missing again, the voice. It's not loud enough. Excuse me, sir. I think the voice is missing. Voice is missing. Excuse me, sir. I think I cannot hear your voice, and the rest of the audience cannot hear it. Yeah, I think that's thank you. Thank you, Dr. Panji Triatyaksa. And now the visiting lecture 2022 is officially open. At the moment, we'll proceed the short photo session. For all participants, I would like to have your cooperation to turn on your camera for this session. And then forget to show your teeth, guys. Okay, on my mic, guys. Belum pada open kamera. Let me give you a little reminder to turn on your cameras for this session. Belum pada open. We will take the picture 4 times, so hold your smile, guys. On my mark, 3, 2, 1, cheese. 3, 2, 1, cheese. Another one, 3, 2, 1, cheese. Thank you for your cooperation. Again, thank you for your cooperation. And now we are about to start the first session on today's event. We are proudly inviting a lecturer from Universiti Teknologi Malaysia, Dr. Nilam Nur Amir Sjarif. And as for the topic for today is what's so exciting about data science. And also, I would like to invite the moderator for this session. She is no other than our own researcher, lecturer with the field of interest in intelligent system. Without further ado, please welcome Ms. Khadija Eskom MCS.
Okay, thank you, Vicky, for the time. It is my pleasure to be the moderator of this session. The Honorable, the representative of the Dean of Faculty of Science and Mathematics, Universitas Diponegoro, Dr. Panji Triatyaksa, the Honorable, the Head of Department of Informatics, Faculty of Science and Mathematics, Universitas Diponegoro, Dr. Aris Puji Widodo, SSI, MT, the Honorable, our visiting lecturer, Dr. Nilam Nur binti Amir Sjarif, from Universiti Teknologi Malaysia, and Clara Vania, Ph.D. from Amazon, UK. The Honorable Lecturer and Staff of Department of Informatics, Universitas Diponegoro, the Honorable all participants, the proud students of Department of Informatics, Universitas Diponegoro. Assalamualaikum warahmatullahi wabarakatuh. Good morning.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you. First of all, let us thanks to the Almighty Allah Subhanahu wa Ta'ala, because His blessings we are able to join this event, visiting lecturer held by Department of Informatics. Ladies and gentlemen, now we are come to the first session of this visiting lecturer. And in this special occasion, we have our special lecturer, Dr. Nilam Nur binti Amir Sjarif, senior lecturer from Razak Faculty of Technology and Informatics, Universiti Teknologi, Malaysia. So we would like to give our special thanks to Dr. Nilam and also welcome Dr. Nilam to this event.
Thank you very much.
Ladies and gentlemen, before we start this session, it is my pleasure to introduce the profile of Dr. Nilam. Dr. Nilam Nur binti Amir Sjarif achieved his Bachelor of Science in Computer Science and Doctor of Philosophy in Computer Science from Universiti Teknologi Malaysia in 2010 and 2015 respectively. Dr. Nilam is currently a senior lecturer in Advanced Informatics Department, Razak Faculty of Technology and Informatics, Universiti Teknologi Malaysia since April 2016 to present. Previously, Dr. Nilam has working experiences as a researcher in Big Data Center, Universiti Teknologi Malaysia since 2015 till March 2016. And Dr. Nilam also has so many experiences of serving as academician, researcher, and also consultant. Her subject matter experts are related to machine learning, data mining, computer vision, and pattern recognition. As academician, Dr. Nilam has many experiences in delivering lectures about business intelligence and machine learning for business problems for many years in UTM. Dr. Nilam is also in charge as Program Coordinator Project Master by TAC course from 2020 and 2023. As researcher, Dr. Nilam has a lot of publication in the prestigious international journal and also international conference related to her research area. Her latest publication is published in IEEE Access entitled Decision Fusion for Stock Market Prediction, a Systematic Review. And as a consultant, Dr. Nilam has also many experiences in consultation and research projects related to system development, data analytics and visualization, cybersecurity, and etc. Now, Dr. Nilam is also actively participate in some professional membership, such as Microsoft Certified Azure Data Scientist Associate from 2020 till 2023, Association for Computing Machinery. This is the prestigious international professional association in computer science since 2017 to present, and also Malaysia Robotics and Automation Society since 2017 to present. Ladies and gentlemen, today Dr. Nilam is going to talk about one of the current interesting topic in artificial intelligence, especially data science, which is in line with the Dr. Nilam research interests and experiences. Therefore, there must be a lot of valuable information we can benefit from Dr. Nilam's lecture today. And in this session, we have two agendas. The first agenda is the main lecture from Dr. Nilam, about 90 minutes. Then the second agenda is a Q&A for about 30 minutes. We expect all participants to be actively participate in the Q&A session. During the session, you might type your question in the chat panel, or you may also deliver your question directly to Dr. Nilam in the Q&A session. Well, ladies and gentlemen, let's start the first agenda in this session. The main lecture presented by Dr. Nilam, and the topic of the lecture is what's so excited about data science. Without further ado, Dr. Nilam, the stage is yours.
Thank you very much, Ms. Khadijah, for the briefly explain about my detail actually, all right? Before that, can I share my slide? How to share?
Yes, of course, Dr.
Wait. Okay, can you see my slide?
Yes, we can see your presentation.
All right, thank you very much. Thank you very much again, especially for the what we call it, Dr. Aris Puji Widodo, Dr. Panji Triayaksa, and also Miss Khadijah for inviting me on what we call it, especially on the knowledge sharing, right? So when I seen all of the participants, I think that is a lot of you are what we call it, join this session, make me so nervous actually, all right? So I believe all of you have a lot of experience compared with me, right? I'm just what we call it, a junior in data science, right? Okay, based on the what we call it, based on the informations given by the Miss Khadijah, all of the participants are including on the semester 5th, which is they have experience on the machine learning, machine learning and AI, right? So I tried to choose what is actually the relevance of the topic with especially of the undergraduate. This is undergraduate program, right, Miss Khadijah?
Yes, this is undergraduate program.
All right, okay, I try to share what is actually the experience. This is more on the experience of me, right? When I move into the field of the data science. All right, but before we proceed to the presentations and knowledge sharing, is it possible if I can communicate with you in a dual language, maybe in Indonesian and English at the same time?
Yes, okay, it is
Alright, okay.
your
That's good.
pleasure.
Itu sangat bagus, right? Okay, actually I'm very what we call it surprisingly, right? What we call it, Universiti Diponegoro inviting me because I believe they have a lot of what we call it, a lot of professor or doctor that which is might be good for knowledge sharing, all right, but I try my best to sharing my experience, knowledge, what I know about the data science. Okay, so before we proceed to the knowledge sharing, maybe I want to what we call it, give us some again some review about my what we call it, my journey to the data science. Is actually before this, if you look at to the what we call it, to the my degree, right? Mostly my degree is under computer science, and I go directly to the what we call it, to the research of Ph.D. research into what we call it, video surveillance, right? So before I get the idea about this research, actually I also don't know what is actually this background, data science. But when I going through on my research path, right, and I think that this is actually the data science, and from this time I want to share to all of you, especially for the undergraduates, whereby it's actually similar with my field, with my background, whereby and want to know what is actually data science can do when you already done your graduations, right? So before we proceed to the sharing, it might be possible I want to get your cooperations to get some idea. Have you heard about the data science before? Can you go to the Mentimeter with the voting code, and maybe we can get a 3 minutes or less than 3 minutes to get the idea. Have you heard about the data science? I want to see the ranking first. Is it possible? Can you go to the Mentimeter? Sorry. Where's the...
Okay, all students, you might start to join the voting code.
Mentimeter? I just want to get the idea. Have you heard about the data science before? Oh, that's good. A lot of you have been heard about data science. 46, 48 mentions about, yes, you already heard about the data science. 53, 54, it keep increasing. 59, 62. Okay, ada lagi? 71 of you, 73. That's good. Easy for me to explain about the data science after this. 76, 78, 79, 80. Finish? Okay, I think all of you have been heard about the data science, which is when we seen the voting, almost 83 people have been heard about the data science. But don't worry about the 5 people who are never heard about the data science, because I believe when you going through to the data science and you aware this is actually the data science that you have been what we call it done, right? So thank you very much for the cooperations. We can see that almost all of you have been heard about the data science. Okay, so let's move to the another slide. Right. My topic is what's so exciting about the data science. Of course, we want to see, is data science a good career choice in the 2022 and beyond? All right, because we can see that all of the what we call it, especially on the global program or global academic program, have been mentioned about the data science. All right. If you think that the data science is a good career choice in the 2022 and beyond, yes or no, or maybe, all right. So this is actually what we call it, we can see that data science is actually the good career choice for the SEC 2022 and beyond, right? Don't worry, because data science is actually work for everyone, right? So it's actually a data science is actually a 21st century skill for every disciplines. And surprisingly, I heard about your faculty is actually a multidiscipline, what we call it, multidiscipline programs that included chemical, included the technology and so on. This is actually a good starting to create a job, data science job skill, right? It's actually should, everybody should have this data science skill, right? For your informations, right? In a business, Harvard Business Review, this actually have been predict that data science will be a promising career, whereby many of them start scaling their what we call it, upskilling themselves, and also transition them into a data scientist or data analyst, where this is actually this role is actually most prestigious global organizations required, right? So why I mentioned about this is actually 20th century job skill for every discipline, right? If you look at to here, right? Based on the what we call it, the finding, based on the review of the business, what we call it, business review, they mentions also that data scientist is actually a sexiest job of 21st century, right? See, this data scientist is actually the sexiest job, right? They have, when we said about the sexiest job, is actually a popular and the famous job of the in the global, right? So I found it in the what we call it, this article based on the Harvard Business Review. Also, they mentions about the data science is actually emerged with the plenty of promise and a number of organizations to join to hire a best talent in this field. All right. So almost a decade until today, if you can see that data science job on job sites search, especially they required the what we call it, the experience of the data engineering solution or maybe data architects role for the data science role. All right. Another than that, I want to share to you another motivations why it's so exciting when you learn about the data science. This is actually the findings of the US Bureau, what we call it, statistic level, whereby they find out that analytics and data science is actually a demand futures job, right? We can see through this finding, referring by this statistic, it mentioned that the numbers of the data science field will be predicted increasing into a 27.9%, right? So kita boleh lihat ya, 27.9% through to 2026 is actually very a lot, right? And it's roughly 11.5 million new jobs will be created, right? So kalau kita kata nggak ada kerja, sekiranya kita nggak ada kerja, so it will be something like is unusual, because if you have a data science experience or knowledge, right, it's you will be what we call it participate this as a role of the data science job, right? And we can see also, right, from the informations here, right, this career also has been called the most promising career, right, by LinkedIn, and the best job by the Glassdoor, right? So why LinkedIn and also Glassdoor mentions about this is actually the promising job, right? Because if you notice that when you want to find a job, right, so you will refer to the link, you will update your profile through the link, and also you will refer to the Glassdoor, right? So later on, guys, especially for the students who will be graduates, right? If you want to see what we call it, where you want to get a job, right? Especially in the IT positions, maybe data science positions, you can refer to the link and also Glassdoor, because this is actually, they provided you a lot of opportunity to what we call it, to get a job based on the data science, right? They also mentions here link and also the Glassdoor. This is because the demands of the data science is very high. The salary is also competitive. So when we talk about the salaries, I will show to you later what is actually the salary, because I believe if a student will be graduates on their program, they will want to see what is actually the career that give you a high salaries, right? Okay, so in here, another than that, right, we can see that through the Glassdoor website, global search website, it mentions that the data science area is actually the best job in the US, right? So with the growing of the data science, it could be you can participate in the what we call it pursuing your. They have a lot of what we call it programs to pursue your study, especially on the data science program. Okay, so what next? So this is interesting. Another interesting part of the data science. I get these articles from what we call it market and markets report. They mentions about data science platform market with a COVID-19 impact analysis by a components, platform as service. It could be include a business function and also deployment mode, organization size, and regional. So this is actually, they will predicted, they will forecasting on the data science platform will be increasing more to 2026, right? So based on this report that they mentions about, the data science platform market size is actually projected to grow from USD 95.3 billion in 2021 to 322 billion in 2026. So they have what we call it is something like market size is very big, right? And then what we can see here, right, due to the impact of the COVID-19, I believe all of you have been orang kata terkesan, right, because of the COVID-19. Is automatically 100% tuned from the physical, from the manual into automated, right? So it give impact to the global economy. For example, directly impact to the production and demands, causing a supply chain and market disruption, right? Another than that is actually data science platform software are actually adopted for banking, financial service, and insurance, right? Retails, e-commerce, telecom, media, and entertainment. I think all of the applications have been adopted data science platform, right? Okay. And also, this is actually the major vendor that we can see who are the key players of the data science platform. For example, IBM, Google, Microsoft, SAS, AWS, Network, Clara, and so on. I believe you are quite familiar, right, with this key player. All of you have been using a Google, right? Microsoft, and then if you're going to be what we call it, IBM, Teradata, right? And also SAP, Anaconda, and so on. This is actually a major data science platform vendor, right? So this is the questions. Another interesting question, is data science demand in Indonesia? Because from the previous slide, I have shown that this is actually the demands by the global, right? So is data science ready for in Indonesia? Right, so this is actually the interesting article and interesting finding I found last 2 weeks about the data science demand in Indonesia, right? This is actually the what we call it the finding why data science is demand in Indonesians. If you look at to this report, right, this is actually a report by the datamatch.com. They tried to find out the what we call it, the average salary of the data science. It's quite a lot, right? If you look at to here, they have a lot of number, right? I think, if correct me if I'm wrong, if I set the rupiah, right? 121,241,000, how to say it? Okay, can somebody help me to set this, because it's a lot of what we call it numbers. It's almost 121 millions per year, right? We can see that this is actually the sexiest job and the requirement, the hottest job of the 21st century. Because we can see if you have a data science experience and also including the AI, artificial intelligence, you can, what we call it, can get the average salary, right? This is actually just average salary. How about if let's say you have experience, you have experience, 2 years experience, 4 years experience, 5 years, 20 years experience of the data science. Of course, this you're gonna be seeing the average salary will be keep increasing, right? Okay. So I got this, what we call it, these articles from the FinTech News Malaysians about in the September 1. It talk about the data science leverage in Indonesia, right? They mentions how Indonesian BNPL giant leverage the data science to drive innovations, right? If you look at to here, BNPL, do you have any idea what the BNPL stand for? Can somebody help me? What is actually the BNPL stand for? Any idea? No idea? I think all of you have been using. This is actually have been using every e-commerce, especially in Shopee and so on, including the e-commerce investment. What we can say BNPL is actually stand for buy now pay later, right? Apa orang kata bayar sekarang tetapi ada bulan-bulannya, right? Buy now pay later. This is actually the investments that aim to provide a better fintech solution to the Indonesian market, right? Why they mentions about they try to leverage of data science in these services? Because they identify that they have a low penetrations of credit cards used in Indonesia, right? Bukan semua orang ada credit cards, right? So if let's say you don't have any credit cards, then you can apply a buy now pay later, right? So the second reason is actually the using of the mobile phones. I believe all of you have a mobile phone, not only one, it could be 2 or 3 mobile phone, right? For example, maybe Bu Khatijah, Miss Khadijah have 2 mobile phone, one for what we call it, office, right? And one for the personal, right? And mungkin mana tahu Dr. Aris Puji also dah have a 3, right? So satunya untuk shopping, satunya untuk for the purpose of the office, and another one mungkin ada penggunaan lain lah. Alright. So this is actually why the Indonesians started to use data science to leverage in the service of BNPL. Right. Another than things is we can see another news articles about the Indonesian talents. They try to find out the demand rise for data scientists and AI talents in Indonesian, right? So in these articles, they try to find out what is actually the talents can come out with a data science. It could be the talents on artificial intelligence, machine learning, big data analytics, Internet of Things, right, in digital marketing, this is actually the demands of all of the industry that adopt a technology, right? So we look at the last one, which is part of here. This is very interesting part, whereby in here we can highlight that in the Indonesian is actually they already started to have a data center cooling for the global market. So data center cooling is a very good, what we call it, very good apa orang kata demands lah, right? Because everything is about the data. So we need something like a data warehouse, right? To what we call it, to collect your data, right? So Indonesians is one of the what we call it, data center global markets in the world, right? So it's quite what we competitive with others what we call it, others country, for example Korea, UK, USA, Australia, Brazil, China, French, and Germany, whereby this is actually the big country that already built their what we call it, their technology. So Indonesian is actually the part. So you should be proud, right? What we call it, your country already started on the what we call it, the talents about the data science, right? You already have a services, you already have a platform. So why not you can use it in order you to what we call it, to get the opportunities about the data science in order you to build your own economy, right? Rising economy. This is actually what we call it. I think this is actually the best information for the graduates, right? Especially on the student graduates, all right? Why what we call it, data science is a very hot, right? And how much the data science make in Indonesian, right? If you look at to here, I can see from the previous slide, I mentioned about the data science and AI can be averaged almost 121 millions, right? So 121 million or something, I don't know. But in here, what we can see here, the monthly average of the data science salary is almost 25 millions. It's almost 26 millions per month, right? So this is very what we call it, very interesting and very high, what we call it, high demands in Indonesia, right? So in here, right, based on this, this is actually the updated, right? The updated from the Glassdoor. If you want to look at the Glassdoor, if you want to find any job search about any job, right? So you can refer to the Glassdoor searching, right? In here, this is actually the updated of the informations about the data science job. I got it from the September 4, 2022. This is the new one, right? Maybe now in the 10th September, we'll be increasing the salary lah, right? So we can see here what we call it, the data science in Indonesians already have what we call it, leverage, right? They required require the experience of data science, right? And for this slide, I also share to all of you, right? When you come up with the experience of the data science, right? Starting from the first year, 0 to 2 years, without any experience, right? Without any, maybe just some the what we call it, just a fundamentals of the expert, right? It's quite a lot, right? It will keep increasing. The percentage of the data scientist average salary keep increasing change. For example, if you can see here, 0.0 to 2 years experience, you already have a 12 millions rupiah. Is quite a lot, right? For the new or for the new graduates, right? Now, if let's say you have a 2 to 5 years experience, it will increasing not 2%, 10%, but increasing to 26%. It's a very high demand, right? 5 to 10 years, and then if let's say you have a more than 10, 20 years, it could be a what we call it, it's a keep increasing lah, right? So, if let's say, if you want to compare data science average salary different by the education level in Indonesia, right? If you are undergraduates, bachelor degree, when you enter to the field of the data science, it could be you can reach about 14 millions rupee, right? If let's say master degree, it will increasing 33%, and PhD will be increasing 42%. So this is very interesting, right? We want to see that if let's say you have the experience of the data science, and then you have expertise of especially on the data scientist, right? You will be what we call it million ataupun trillion lah, right? So in here, I got from the Glassdoor the what we call it, the famous job that open for the data scientist, or especially on data science experience. We have a Bukalapak, we have Tokopedia, Telkom Indonesian, Astra Internationals, Telkomsel, and they have many more of the what we call it industry in the Indonesians required a data science, right? So this is actually the open job for the graduates who already finished your program, right? Try to what we call it, to go to these companies and then proceed to your data science area. All right. So some of the people's query about, can I do data science without a computer science, right? If you notice that, if I know that from this faculty, you mentions about the multidisciplines of the what we call it area of the programs, right? So for me, based on the what we call it based on the survey, they mentions that if you don't have any data science experience, yes, you actually can what we call it do a data science. It's actually some of them mentions about, can you become a data scientist without a computer science degree? So it's actually, in short, the answer is yes. Don't worry, because data science is actually the multidisciplines area of field, right? It's not data science is not only a computer science subfield, but it's including each of the fields that you are expert, right? As mentioned by what we call it, the Professor DJ Patils mentions that data science doesn't care about what you measure in or if you are even a degree, but it's actually matter about the data. If you have a data, then you can find out a solution or decision made based on the data that you have, right? Okay. So this is some example lah, how you to become a data scientist without a degree. All right. So if let's say you have a data scientist without a degree, especially on the computer science or so on, what you can do, maybe you can create your perfect prerequisite. Maybe once you graduate your program, you can try to what we call it, try to join any professional certificates of the data science and so on, right? So another than things is actually maybe you can what we call it refine your data science skill, all right? Because if let's say you don't have any what we call it idea, you don't have any experience on the programming language, maybe you can try to join any specific programming language, because normally for right now they have a lot of a lot of courses, the free courses that give free courses for the data science, right? So another than that, you can try practice with data science project, right? So what is actually the data science project that you can do, right? So I will share to all of you later on what is actually the comments applied that you can do for the data science, right? And build your portfolio, right? And maybe you can consider related job, even though you have what we call it, have expertise, have a knowledge into a kimia, maybe into a medical, right? So you can also what we call it, implements or employ or deploy a data science in your area, because in the data science it's actually a team whereby you required what we call it the expertise in a domain, for example the business domains, right? And then merge with any developer, right, to create a data science applications, right? So what next, right? So if you look at to here, right, this is actually the career path of the data science, right? If you look at to here, right, data scientist is actually a combination of all of the area paths, whereby it's including the data analyst, data engineer, right? So maybe a business analyst. So in order to get a data scientist. So if let's say you want to see as a data analyst, you want to become a data analyst, it's actually fundamentals or something like the fundamental levels of your data science, whereby in here you try to analyze your data, all right? The software developer, right? The data engineer, and also big data engineer. All right, so you can see here, this is actually the career path of the data science. If let's say you have a more experience, then you can become a senior of the data scientist, and why not, maybe you can become a director of the analytics, right, in order you to become a expert in your area, right? If you have any questions, you can interrupt me here, because maybe we can get some formal communication, right? So we already seen there have a lot of opportunities, especially in the building your career of the data science, and especially on the salary, right? Especially on the investments of your country in terms of the data science, right? So we want to look at what is actually a data science, right? Data science, we can see here, it is actually defined as what we call it can be defined as a multidiscipline, right, interdiscipline field of a study that use data for various research and reporting purposes to derive insight and meaning out of that data, right? So we can see it's an interdisciplinary field. It could be a statistic, it could be mathematician, it could be a business part, right? That combine and do some various research and reporting purposes. Data science, if you can see here, when we talk about the interdisciplinary, is actually a combination of the knowledge and also the tools, right? A combination of knowledge, a combination of programming abilities, maths, statistic knowledge to extract a useful insight of data, right? Because you notice that when we deal about the data, it's not a simple, it's a very complex, right? It's a very, what we call difficult, because if you can see that the data can be included as what we call it, structured data and unstructured data, Right. So what is actually structured data and unstructured data? And this is actually the data that we're going to be used to find out the outcome or decisions of the business decisions lah, especially. So, but before we go to the unstructured data and unstructured, what is actually the meaning of the structured and unstructured? Maybe we can, I want to share to all of you the common terms that used in the data science, right? So, this is actually terms that common used by a data science. For example, data science is actually is a scientific method, algorithm and system to extract knowledge or insight from a big data. Why they mentions about the big data? Because in the 21st century, we gonna be facing a large amounts of data that we included the big data problems, right? So in here, in the data science part, when you what we call it, extract a knowledge or insight of the data, it could be you need to know about the predictive model or predictive advanced analytics especially, right? So data analysis, you need to know when you involve in data science, you need to know what is actually the process of you need to use in order you to define the decisions, right? And another part is data analytics is actually you try to discover, interpret, and communicate the meaningful patterns of the data. And data mining is actually the process of discovering patterns in a large data set, right? So in here we can see that they have a connection, data science with the artificial intelligence, data science with the machine learning and the deep learning, all right? So we can see that data science is actually cover up the umbrella for the whole process and the whole modeling of the model, data science model, right? So for example, the artificial intelligence, human intelligence, all right? Artificial intelligence is actually the human intelligence that exhibit the missions, whereby I believe all of you have been used this artificial intelligence in your daily life. For example, the comment of the student when they have what we call it time to rest, you will use what we call it you're gonna be use your mobile to play your games, right? So artificial intelligence can be used in the game part. You can apply in the natural language processing, whereby it's a very good applications, because normally we are focusing on the social media network, right? Social media analysis. So NLP is a very good part of the artificial intelligence to know that what is actually the almost, for example, the customer behavior, right? You want to see the emotions, you want to predict, you want to analyze the emotions in the social media, right? So you want to see you can predict the purchase through the e-commerce, for example, Amazon purchase predictions, right? You can see that artificial intelligence also apply in a smart email categorizations, right? Just for examples here, right? When you do a Google, when you read your email in the Google in the Gmail, right? So you find out, right? The first thing first, you can see that they have a lot of categorizations. For example, inbox, they can find out, classify a spam. They also can classify any categorizations in the email, right? So this is actually already applied in the artificial intelligence. All right, but in the artificial intelligence, you need something model or the approach to get the intelligence of machine. For example, here, right, you can use a machine learning models to approach to achieve the artificial intelligence, right? And at the same time, when if let's say the machine learning cannot deal with the with the data, then you can move to the deep learning algorithms, deep learning technique, right? So this is the example for the deep learning have been applied for what we call it for the industry, for example, self-driving car, for example, Tesla, right, robotic, right? So now we can see that a lot of robotic have been embedded the artificial intelligence, right? For example, we have robot Sophia, right? Have you heard about the robot Sophia before? Right? Robot Sophia is actually one of the what we call it the good examples. I think the good examples that achieve the artificial intelligence that can be like as a human, right? So we can see also the robotic, for example, now during a pandemic, we can see that they have a machine that can bring us meals. All right, we don't want to have a contact with people, then they use the robotic in here, right? They also can use a drone to what we call it, to get the accuracy of to see the environment's accuracy, how they can detect detect the object detection and so on. So this is actually the common data science terms that we use in a daily life, right? So by Professor Rafael Rizeri mentions, as more and more organization attempt using a data for the first time, there will be a plenty of new opportunities that only a person trained in data science will be able to leverage. So in here, we can see that if you have a data, then you can see that they have a good opportunities, they have a good knowledge or informations that you get from the data that you have, right? So remember, I mentioned about the in data science, due to the large amount of data, they will be included the data in a structured and unstructured. So why I mentioned about structured and structured data, right? If you see here, right, data is actually produced a lot. It's a very large data have been produced daily. It is almost about 2.5 quintillion bytes of data have been generated, right? So in here, we can see that the data can become from what we call it, from the emails, from the social media, tweets, maybe in the TikTok, maybe in what we call it in a Facebook, in an Instagram, right? You are sharing your video, photos in your social media. It's not also included in the cloud, whereby you save all your videos and the photos, right? So this is all about the data, right? It's created a lot of data, a large amounts of data. And we can see that according to the recent estimate, by 2020, the digital ecosystem will be approximately produce 44 zettabyte of data, right? Projected to reach 180 zettabyte by 2025, right? Can you imagine how big that data created in our daily life, right? Now we can say that we just can know the data, that the common data that we can see is actually tera data lah, because commonly you use, all right, in hard disk, in the external hard disk, we have what we call it 4 tera, 8 tera, right? So can you imagine in a 44 zettabyte is how many zero have been created in that data, right? If let's say terabyte, it might be 1,000 and 1 million byte, right? It's something like they have a 6 zero in front of the one. But how about the zettabyte? Can you get any idea? Zettabyte, how large is that, right? Because we can see here, if let's say terabyte is something like 10 to the power of 6, all right? Maybe 10 to the power of 3, but for the zettabyte, it could be included 10 to the power of 21 zero. So I think this is very, very large, and it can be, we don't know how to spell out with the zero, right? So, and they still keep increasingly, because most of the people right now are depending on the what we call it gadget, right? Maybe depending on the social media, it keep increasing, right? It might be predicted to reach 180 zettabyte by 2025, right? So what is actually the data? In here, we can see that data is actually refer to the collections of facts usually obtained as a result of experience, observations, or experiments, right? So if you look at to this slide also, they have mentions about the business also demands about the data, informations, and analytics, right? So in the business world, it's actually knowledge is not just a power, it's actually can guide you to the better enterprise decision making. All right, it's also what we call it. It can direct you to the best directions in your organizations, right? And it can also we want to see that based on the data also can you need to have what we call it to get the informations and analytic and knowledge is not as simple because data in the unstructured formats is a very you need to have some process lah to get the information and knowledge. All right, so it might be possible once you have a data that you collect from a different sources, right? You need to clean and you need to have a consistent format. Maybe you can what we call it to have a good formatting and so on. All right. So remember I mentioned about the data in the data science. All of the data sets are referring to the data, right? So data we can see here is due to the large amounts of data have been created daily life. So we can say that our problems, our what we call it difficulty is how we want to handle the data, right? So in here, what we can see here, this is actually the 8 V's big data problem, because before this, during 2020, during 2010, which is the starting of the big data, right? Only 3 V's or 4 V's we need to cater. But now we can see that 8 V's have been included in the environments of big data. For example, the first one is the volume. Can you find the informations of you looking for? If let's say you have a volume, something like it depends on the size of the data that you have, right? Another than that is actually the value, right? Is something like, can you find it when you most need it? Something like you just having a big data is no use. So what is actually how you can turn that data into a value, right? Veracity, something like the trustworthiness of the data in terms of the accuracy. When you collect the data, right? How the data is this data is a good quality of the data or not? So in terms of the accuracy lah, right? The variety is something like the different types of the data, right? Remember when the data included in a structured and structured format, it could be email, it could be video, it could be what we call text, right? It also including a photo or image, right? So how you can include it, all of this data in order you to analyze this data, all right? Velocity, all right, is something like including the speed which the data is generated, right? So sometimes if let's say your data cannot cater with a single processing, you need to have a parallel processing to run your data, right? Another than that is also included visualization, right? In here is something like how you visualize it into a readable and accessible, right? Because now in the visualizations, we also have what we call it a lot of platform, the business intelligence platform to visualize it. For examples, Power BI, Google Analytics, all right? We also have a Tableau and so on. This is actually how you can use the visualizations in order you to easy to read and also easy to accessible. All right. The 7th one is actually viscosity or variability, means that the data whose meaning is constantly changing, right? So in here, we can see that viscosity is something like, does it stick with you, or does the data can be called for action, right? Because of variability. And last but not least is virality, right? So what is actually the virality? Right, virality is actually included the tendency of the image, video, or piece of information to be circulated rapidly. Right, what we can see here, virality is actually included in the social media. So you want to see how you can convey your data in terms of variability. So all of this data can be included when you analyze your data for the best decision making. Okay, so when we talk about the data also, right, it's some things like the best what we can refer is actually the oil, right? It's some things like we can say that data is the new oil, whereby this is actually was coined by the Clive Humby, whereby it's expressed the data is a new oil, right? So in here, what we can see here, right, with the data, obviously, right, you need to have a analytic and comprehensive of the data that you need to take, all right, that you need to have, right? So what we can see here from the data, you're gonna be capture a lot of information. For examples, in the different domains, right? You capture different domains in order you to lead the decision, the best decision. That's why in here, when they mentions about data is the new oil, once you have a data, just imagine they have a lot of elements, they have a lot of sources ataupun sumber when you crude your oil, right? So it might be possible, just imagine in the technology right now, we can see that they have a lot of domains or industry that created the data, for examples, bill, emails, right, and so on. Right, so you refine it and then you try to identify what is actually the best impact decision in a real time in order you to live, work, and learn based on the data that you have been transformed into a knowledge and information, right? So do you have any idea what is actually data, information, and knowledge? Do you have any idea, guys? Maybe someone can try what is actually data, information, and knowledge, because I believe almost 80, more than 84 people have been heard about the data science, right? Maybe you can get idea what is actually data, information, and knowledge. Anyone want to try? Anybody want to try what is actually data, information, and knowledge?
Yes, there is a student, Fahril Gibran Al-Ghani,
Is there
Dr. Nilam.
any student want to try what is actually data, what is
Yes.
actually information?
There is one raised hand.
Saya
Fahril
maaf,
Gibran.
saya enggak dapat lihat sebab most is actually presented mode. Maybe boleh bersuara.
Okay. Yes, Fahril Gibran, you might turn on your microphone and deliver your opinion.
What is your opinion about data, information, and knowledge?
Okay. Satria, you might set Fahril Gibran to be the co-host, so he can turn on his microphone.
Okay, thank you for the opportunity.
Yeah.
So I think, in my opinion, data is information that data doesn't have any meaning. Then the information is a collection of data that have a meaning, and the knowledge is something that we can gain a decision from the information.
Mhm. Right.
Yeah, I think that's the difference between data, information, and knowledge.
Right. Thank you, Faril. All right, for the trying. All right, data you means that they have no meaning, and information is you get from the data, and knowledge you get from the information. All right. Is anyone want to try? To try for another one, but it's actually data, information, and knowledge. Thank you, Faril. Ada lagi yang mau cuba?
Boleh pakai bahasa Indonesia ya.
Iya, bisa-bisa.
Kayaknya Dr. Nilam bisa mengerti. Silahkan.
Mau dicuba? Ya, Chandra.
Yes, I think about the data. Data is a collection of facts in a row or are unorganized from such as number or characters or image, so on. Then for information, information is the next building block of the DIKW pyramid. Or information is the collection of the data that has been cleaned of error and further processed in a way that makes it easier to measure, visualize, analyze for a specific purpose.
How about the knowledge?
And the knowledge is how the information derived from the collected data.
All right. Thank you very much.
Yes.
All right. Thank you very much, Chandra, for the what we call it for the trying. For the Farid and Chandra, is actually both of you actually correct. Whereby data is actually represented as what we call it. Is presented as what we call it raw, random, and organized. Remember, data is something like it come into unstructured and data structured and unstructured format, right? So it could be raw, random, and unorganized, whereby is for what we call it for the informations. This is actually the data that has been organized, right? Remember, when you collect the data in the different format, just for example, I believe all of you have the experience working on the database management, right? Especially in Excel, right? So when you deal with the column and also the row, right? When you want to do a what we call it analysis about the data, right? The comments when we get from the report is actually the data that have been summarized. But in here, in the data science, what you are required is from the raw data, you need to organize that data into a structured way, right? Not what we call it data that have been summarized, right? So in here, informations, when you deal with the information, is something must be included, the process, in order you to structure your data, right? In order you to gain your knowledge, right? Last but not least, a knowledge, whereby we want to know what we know, accumulation of the past experience and insight, and also interpret it into a meaningful that can give impact or actionable of the data itself, right? Okay, maybe I can give us some scenario lah. Okay, sekarang ni saya rasa udah almost di sana 11 jam 11 ya, Miss. Di sini udah 12, means that we're already lunch hour, and I believe all of you can feel hungry, right? So this is actually the simple concept that that we can differentiate between the data, information, and knowledge. Let's take a look at how a foodie will approach a concept. Do you have any idea? Right now, I seen that data is the raw, unorganized, right? And information is something like process, and knowledge is actually the actionable and the output, right? So based on this scenario, can you give me some idea in a soup of bowl that you made right now, which is the soup that you seen here? what data are commonly used and what informations that you get and what actually the knowledge that you have. Data, anyone? Anybody want to try? Ada siapa-siapa yang mau cuba? Apa itu data? In a soup of pool, you can see they have a lot, right? So, how we can identify, how we can assume this is actually data and this is actually the information and this is actually the knowledge. Ada siapa-siapa mau cuba? When we say about the raw data, so apa yang kita boleh lihat di dalam soup of pool ni, data apa yang perlu ada di sini? Ada siapa-siapa yang mau cuba? Like Fahril mentioned and Chandran mentioned about the raw data. So what actually the data that we can see when we want to make a soup? Mungkin boleh type juga di sini. Di chatting room. Enggak ada yang mau cuba? Okay, Faril mentioned data is the ingredient of the food. Okay, what actually the ingredient, Faril? Contohnya apa ingredient kalau kamu mau buat sup? Carrot. Okay, what else? Beans, right. Salt. Okay, potato. Any else? Water, yes. Broccoli, right. That's good. Celery. Any else? Chicken and meatball. Okay, thank you, Vicky. Right, any else? All, yes. Pepper. Wah, ini bikin sedap ini sup ni. Cabbage, yes. MSG. Onion. All right, thank you. All right. So, when you see here, this is actually the data, right? Just imagine what we call it, all of this data is actually raw, right? With the what we call it onion with the apa ada kulitnya, right? With the cleaning and so on. So what about the information? Right. Okay. We stop with the data, then we move to the informations. When you have the data ingredients, what you made to become the information? Please type. Ada siapa yang mau cuba information? The step on how to make the soup. Thank you, Mr. Sandy Kurniawan. Any else? So what actually the step that commonly used to make the soup? Boleh listkan apa dia stepnya? Kita udah ada onion, we have a cabbage, we have a carrot. We also have a MSG and salt and so on and so forth. So what you are doing for that ingredients? Adakah kamu semua akan masukkan semua ke dalam bowl? Masukkan air. Wash the vegetable first. Yes, thank you Mutaz. Any else? Once you wash, what you are doing? Onion, carrot must be chopped. All right. Thank you very much. Boil the water. Yes. Any else? Okay. All right. So in here, you can see they have a different process. Maybe what we call it, like Sandy Kurniawan mentions about the step how to make the soup. First you wash the vegetable and then you chop a carrot and onion and so on, right? Boil the water, make sure the stove is on, right? Kalau nggak hidup apinya ke mana mau masak kan? So this is actually the process, alright? So next is actually the knowledge. Okay, we start with the informations. We already know the data, the ingredients about how to make a soup, and then the information is actually the step and knowledge. Apa itu knowledge? Mau cuba knowledge? Knowledge is actually the soup of bowl, right? So means that the result, all right? If let's say you put the carrot without wash, then you're gonna see that you will get a what we call it, soup tu nggak sedap, right? So maybe you tengok taste of the food, right? That's correct, Paril. The taste of the food, right? So how we connect this with the data science, including the data, information, and knowledge, right? So what we can see here, thank you for the cooperation students, right? I'm very, what we call it, appreciate to all of you, right, for the feedback, right? So for the data, information, and knowledge, we can see that collections of ingredients sitting on the counter. They include carrot, onions, or maybe if let's say you want to make a chicken soup, then you need to have a chicken, right? And then maybe what we call it, a potatoes, garlic, and so on and so forth. So this is actually the ingredient. Same goes to the data science, what we call it, area, whereby you collect all of the data source from a different domains, maybe from a business perspective, maybe from the what we call it, from different area, right? So this is actually the data that you need to have to collect, right? And then the information is something like the process itself. If you don't have a process of the step, then how is you gonna get the what we call it, the output that you expected lah. For example, if you don't wash your potato, maybe if you don't chop your carrot perfectly and something like nicely, so later on the knowledge will be what we call it, the output of the soup will be not look like what you expected, right? And then the informations, how you use a salt, how much salt you use, right? So all in what we call it, in the data science concept, normally information is actually a process as data science life cycles that included cleaning, and then you identify a missing data, you done the data aggregations, right? Data extraction, data transformation, modeling, evaluation, and so on and so forth, right? So last but not least, for the knowledge is actually the soup is ready for you to eat, or either you gonna be what we call it, going buang ke tempat lain lah. So sekiranya your information is not done properly, the process to get the information is not done properly, it might be you gonna get a not accurate informations lah, right? It's for your business informations, right? So this is how we connect with the scenario of the soup of war with a data science life cycle, whereby you have a data, whereby you collect in the different domains, all right, in different sources, right? It might be included a text, it might be included a video, and also image and so on. And then the information, for examples, you are working on the NLP, they have a certain process that you're gonna be going through, right? For examples, you scratch all of the data, all right, you are from any social media, and then you going through with the cleaning process, pre-processing text, right? And then how you transform a text into a value and so on and so forth, right? If let's say you're working on the image processing, right? It's not as simple just you get the you get the image of the data, and then you get the informations about the data, information about the image, but you need to going through on the process of the image processing, right? Start from the data collections, and then you need to extract the data and the modeling that data and so on and so forth to get what is actually the image is all about, right? So what next? Right. So this is actually some skills needed for the data science. All right. For the entry-level skills, all right, you are required some things like the programming skill. For example, Python. Maybe for right now, right, they have a famous programming language that have been used for the data science. For example, Python, R, right, for the visualizations, Tableau, maybe for the statistic part, for the cloud part, SaaS, right? So this is entry-level skills that are required. On the job skills, right? If let's say you have the programming language skill, mathematician skill, or statistician skill, right? Then you can apply it in the machine learning and AI, maybe in the deep learning, in data mining, data wrangling, right? You can apply in Hadoop, maybe in the natural language processing, right? And not to forget, right, it's not only a technical part skills that you are required, but you also need to have a soft skill, right? Remember, right, you need to have what we call it in a data science, they have a life cycles, right? It's not only directly you to develop the data science project without not knowing about the business understanding, right? So the soft skill that you are required also is a communication skill, in order when you present your idea, in order you present your decision into your clients, right? All your clients understand, all right? The collaboration, they have a storytelling, all right? And then the project management, how you handle your project, all right? So I believe, all right, you already have this skill, right? For example, soft skill, I believe all of you already have a skill in terms of the communication skill, project management skill, all right? And collaborations, storytelling and so on. But just add on in the what we call it, in the knowledge of how you are in the technical part, for example, the Python, at least Python, or maybe the visualization, maybe Tableau, all right? So you can then when you have the skill, you can apply in also in the machine learning and AI to get your what we call it, what applications that you want to apply lah, right? So this is actually the skills that you need to have in the, something like some skills that you required to have in the data science, right? Okay. Kita dah lihat, they have a different skills, they have a meaning of data science. And remember, in what we call it, in the scenario, in the 4D scenario soups I mentioned just now, they mentioned about data science life cycle, all right? So in here, might be I can go details about the what is data science life cycle is all about. If you can see here, they have a 7 life cycles might be used for analysis. All right. So for examples, the first one is a business understanding. Remember, for when you deal with the business understanding, you need to deal with the domain expert. Right. For examples, if you want to what we call it, analyze the customer behavior, in what we call it in the e-commerce, of course you're gonna be go to that that industry, for examples Shopee industry and so on, to get a business understanding how they work and also and so on. And then you also need to ask them what is actually the objective, all right, the objective that you want to use a data science, all right, the objective, and then also to determines what is actually the goal, right? The goal of the, you want to apply a data science. And then you are required to have a project planning in your business understanding. It's something like you're starting with find out what actually the problems of your project, right? In order you to find out the output later lah, right? And then the second part will be included in the data science life cycle is actually the data mining, whereby once you already understands about the business understanding of that domains, you need to collect all in the informations, right? The informations of the data, gather all the information, the data domains, right? And then what you need to know also in the data mining is actually you describe the data. Once you collect the data, it's not just simple that you directly go to the analysis part, especially for data cleaning, but you need to understand, is this what we call it, the data is qualified to proceed for the next data cleaning or not, all right? So you need to describe your data, right, in a surface, and also to of course when you want to develop any what we call it, any applications or any system, you need to what we call it, describe the columns, right? So in here, in the part of the data mining, it's not only you gather your data, but you need to describe the data that you have been collected from that domain, right? And for the third cycle, for the third phase is about the data cleaning. This is actually the most difficult part. Once you gather, once you describe, right, you sometimes will take a time. It's at least 50 to 80% of your time will be focusing on this stage, data cleaning, right? Why? Because once you describe your data, once you have the data in what we call it, maybe in the Excel format, right, or CSV format, you notice that they have a lot of missing data, they have a lot of formatting that you need to transform, right? So what actually the data that you need to select, all right, this is actually the part of the cleaning process that you need going through. That's why it will take almost 50 to 80% of your time to 50% or 80% of your time to work on this data cleaning, right? Because why you need to focus on the data cleaning more? Because if let's say your data is not correctly formatting, it will be later on, once you deal with the modeling or once you deal with the predicting part, it will what we call it, it will show some maybe overfitting of your data, all right, and then it's difficult to present of your data and so on. That's why data cleaning required a lot of time compared to others, right? And then another things, right, for the data explorations, all right, you can what we call it, see once the data is cleaning, all right, what you need to do is you can explore your data in terms of, you can connect, maybe you want to relationship between all the attributes and so on to visualize of your finding, all right? And then in the data exploration also, you can see the quality verifications of your data, right? Does data is correct? Once you select the data, all right, you will identify what is actually the quality of the data that you get, right? Does this data that you have is complete? And maybe you will see again, is there any missing data in the part of the data exploration, right? So in the feature engineering part, all right, in the what we call it in the fifth stage, in the fifth phase of the data science life cycle, you can see that it will include the part of the feature selection and construction. All right. Once you have a data, right, you already get the data and then you already formatting into the structured part of the data. All right, you already done explore, and then you find out, right, okay, maybe these features are needed to proceed for the next predictions maybe, right? So this is a part of the feature selection and construction, right? So for the feature selection is actually the process of cutting down the features that can remove some noise, can reduce some noise and then informations, right? You can reduce the target is to reduce the noise lah of the data. And then next is actually predictive model, right? So normally for the predictive model is where the machine learning are finally come into your data science project. You need to know, right, what is actually the models that you're going to be embed, that you're going to be applied in the data science project, right? Because if you know that in the modeling, especially in the machine learning model, they have a lot of algorithm or model or technique that you can apply. So you need to find out the relevance of the models that you want to compare, right? Because in here we want to see how accurate our data once we apply the model, right? So in here, what you need to do, they have some tasks, specific tasks that you require to have in this stage. For example, selecting a modeling technique, all right? And then in here also, you need to have to generate your test design, right? So what is actually the selecting models? Maybe you're gonna be do for the classification, all right? Maybe you want to use a regression, all right? Maybe you want to use what we call it summarizations and so on and so forth, right? So this is actually some technique can be used. I will show to you another slide, next slides about what actually the technique involved in the machine learning, right? In this phase also you are required in what we call it in the sixth phase also you are required to generate your test design. In here you need to know what is actually the data that you're gonna be split, for example training and testing, or either you want to use a cross validation, right? And then you start to build your models and identify what actually the parameter setting of that model. For examples, all right, you're going to be use decision tree models, right? So you find out what actually the best parameter setting for that models, right? And so and then you try to assess that model, and if let's say, right, you need to revise the parameter setting, then you can do in this phase, right? So dimensions in the machine learning, I mentioned they have a lot of algorithms, a lot of models have been built in a machine learning, right? This is some what we call it informations about the machine learning. If you notice that in a machine learning, right, this can be divided into two parts, whereby we can see a supervised learning and unsupervised learning, right? So in here, in the supervised learning is actually the analysis done to predict the future event or data or trend. So some things like if you have a data and then you have a this data is actually some things like have a teacher lah, right? They have a guideline, they have a guide which is already labeled, all right? So for example, in your data, right, you want to classify a mobile phone mobile phone brands, right? They have iPhone, they have a Samsung, they have Huawei. So you already done label. So they have what we call it supervised learning. But for the unsupervised learning, what we can see here is actually basically used to produce a correlation of frequency. In here, normally the data that you have is actually the input your data is unlabeled. So it's a very difficult for you to classify lah what is actually the data the data that you want to classify. So in here, right, they have a certain techniques that commonly used for supervised learning and unsupervised learning. For example, here for the supervised learning, it could be included classification, regression, right? So for classification, regression is falls under the part of the supervised learning, whereby classification normally we want to predict a target class for each case. For the regression, normally we want to identify the likelihood of the variable. It's good for you if, let's say, you want to forecast something like stock market predictions and so on. We have a time series, right? Clustering, summarization, association rule, and sequence discovery analysis. Right? This is actually the technique falls under the machine learning model. Right? If you look at to here, guys, for the machine learning technique, we have a lot of algorithms have been built, have been proposed by the previous researcher. For example, decision tree, artificial neural network, KNN, random forest, support vector machine, naive Bayes, right? Just for your information, it's a very surprisingly when we seen about the machine learning technique. Normally, for example, classification, it relates to the natural environment. For example, in the model of decision tree, when we go through to the decision tree, the idea is actually the theory of the decision tree come from the concept of the tree itself, right? For example, for the artificial neural network, it comes from the human brain, right? Don't forget, it's actually when you learn something during the secondary school or maybe in the undergraduate especially, it's actually applied in this algorithm, in this technique or models, right? For example, artificial neural network, all right. I believe you already heard about the artificial neural network, whereby it comes from the human brains, right? This is very interesting topic, whereby I just want to share my experience during my secondary school, guys. Actually, I learned about the science, right? We learn about the human brain. They have a cerebellum, they have a synapse, they have what we call it neuron, right? But surprisingly, in the machine learning, they also apply this concept into the artificial neural network. So we can connect, right? It's not simple that when during your secondary school, you learn about the science, you learn about the human, you learn about the brain. It's not only applied in the medical part or medical concept, but it also apply in the data science concept, apply in the what we call it computer science concept, right? So k-nearest neighbor, all right, a random forest is a part of the category of the group of decision tree and so on, and support vector machine. For the regression, I believe you already learned about the maths or statistics, like what we call it kaedah berangka, right? So logistic regressions, linear regressions have been applied. If let's say you what we call it learn about the calculus algebra, is actually included the part of the maths in the regression, right? We have the ARIMA, right? Another technique is actually the unsupervised learning, whereby you can do a sum clustering, summarization, association, and sequence discovery. They have a lot, right? So this is actually just examples of the model included in the machine learning technique, right? They have thousands of the model have been created for the machine learning model. Okay. Okay, we get back again to the phase 7, which is a data visualization. It's actually something that you can communicate the finding with the key stakeholder using Float. Maybe you can visualize it using a Power BI, maybe a Tableau, maybe a simple Excel reporting, and so on, right? And don't forget, all right, we already talked about the cycle. It's actually the iterative. You need to revise back once you achieve all of these things. Does the goals is achieved based on the business understanding first, that you done, right? You get back again what actually the connection does. Based on this cycle, you achieve of your output or decision making or not, all right? So you need to check back lah. Right. Okay. Any question? No question? All right. Okay, I just want to share to all of you the best public data set for machine learning and data science, right? If you need to aware when we deal about the data science, we need to have some repository, right? Whereby you are able to compare your benchmark, especially using for the researcher, right? So in here, I will share to all of you, all right? I find out that pub towards sai.net is giving to all of you the link for you to what we call it, benchmark your data set. Remember, when you deal with a data science, especially on the research, especially, right? You need to have a benchmark data set to compare with your proposed methods, right? So this is actually the best public data set for machine learning and data science list. It's included the link of the Kaggle, UCI machine learning repository, visual data, CMU libraries, and so on. So all of this public data set is actually help you in order you to do some data science project, right? Okay. So I would like to share to all of you, right? This is actually the data science tool or the platform that commonly used by, for example, a student or maybe the organizations, all right? For example, Weka, right? Orange, RapidMiner, SAS, Nime. This is actually the open source or the commercial platform that you can use to analyze your data science. Or maybe you can focusing on the language or programming platform, right? For example, Python, R, Java, MATLAB, and so on, right? Or maybe if let's say you find out that your problem is into a big data problems, you can use also the platform big data programming platform. For example, Hadoop, Cloudera, Spark, Mahout, and so on. So if let's say later on, if let's say you want to know about the data science tool and platform, you can try to use Weka, Orange. This is very simple applications whereby it's a graphical user interface based on the graphical user interface system. It's easy for you to analyze for the simple data. Okay. This is actually I just want to share to all of you. Right, for the cheat sheet from the Swami Chandra Sekaran, thanks to these guys, to this author, they help us to identify the journey, the what we call it, what actually the common method, what actually the fundamentals that we are required to have for the data science. If you look at to here, right, in the first color, this is actually the fundamentals that are required to proceed to the next level, whereby I believe you already have the what we call it knowledge in terms of the linear algebra, right? You also have what we call it know about the reporting and so binary tree, right? And here I believe all of you also have knowledge about the statistic programming. And now you can see that this is actually some examples of the machine learning methods that can be used for the data science. And if let's say you are interested into the natural language processing, you can come up with the text mining part, right? So this is actually very helpful, very meaningful informations that can guide you to the data science part, right? Okay, so we already seen all of the data science can apply in the various domains, right? So we can see that data science is everywhere. It's not only used for the computer science, but it's used for the a lot of domains, right? For example, manufacturing, e-commerce, healthcare, sport, finance, banking, transportation, and also agriculture. So if let's say you said that I did not have any idea about the data science, is something like what we call it, actually you already applied the data science part, right? It's everywhere, right? It's everywhere. Something like you apply in every environments, everywhere, in every domains, right? So all industry and organizations actually awash with the data in this protect age, and data is being created in exponential manners. Data science is actually being used by every industry, right? Data science lead to the smarter decision making. Okay, I just want to share to all of you, this is actually the top data science companies that normally what we call it famous lah or popular, right? I believe all of you know Microsoft, Amazon, Airbnb, Visa, Google, Netflix, what we call it, White Pro, TikTok, right? So this is actually the most company use data science, and we also use their services to achieve our decision, right? And I also want to share to all of you, maybe you want to get the idea what is actually the top big data analytic companies in Indonesians that apply a data science. Right? I got this information from the Good Firm list, whereby all of these actually located on the Jakarta, right? Is for example, Cybertrend, Purple Analytics, Arpadia, Eureka, Databots, right? Nutanix, Tokopedia, Telkomsel, Telkom Indonesia, all of these company actually apply a data science concept, apply a data science, what we call it, data science knowledge, right? So later on, if let's say you interest into a data science, then maybe you can try to apply to this, what we call it, company lah, okay? So last but not least, so what exciting about data science? Of course, you can become a detective, right? Because data science, you already try to learn, you try to understand what is actually the data is all about, all right? The assignment in data science is in the journey toward achieving the three significant kinds. For example, discovery, insight, and innovations, right? You can, what we call it, once you discover your information, your knowledge, then you can innovate your finding, all right? And then data science is the future. It's actually better to be on the cutting edge than left behind, right? And surprisingly, in your country, they already started to build the data science area, all right? And data scientists and machine learning engineers are in the great demands and the forefront of the coming AI revolution. And other than that, data science make me feel powerful, right? Once you achieve what you want, then, for example, the profits that you achieve, the, what we call it, decisions that you want, right? Being able to obtain process and build model out of the data, right? Based on the data that you collect, that you prepare, that you explore, then you will expert in the quality of the data that you have, right? Data science is actually unstructured information and gathering insight. All right, and then you know that data is not simple as you collect, but it's actually including the various of the data, various of the formats, and so on. And last but not least, data scientists help you to improve how humans make decisions and algorithm to optimize your outcomes. Okay, so get ready for the success job of the 20th century, guys. Hopefully, maybe from this experience, from this knowledge, it can give us some idea to you to get to know why the data science so exciting for this 21st century. Okay, that's all for me. Do you have any question? I will pass again to Miss Khadijah. Miss Khadijah.
Okay, thank you, Dr. Nilam. I'm sorry, I have a problem in connection, so I asked the host to set me to be the co-host again. Okay, thank you very much, Dr. Nilam, for your great and valuable knowledge sharing. So all participants, may we give a big applause to Dr. Nilam.
Thank you.
Yeah. Okay, and Dr. Nilam, besides our undergraduate student from Department of Informatics, actually there are also some participants from postgraduate student in Universitas Diponegoro, especially from Magister and Doctor of Information System.
Okay.
And okay. And actually, we get so many valuable and new information related to data science today. And I think the student must be more exciting about data science after seeing the great number of salary they might get in jobs. And also high demanding job in fields of data science. Okay, now we are going to proceed to the second agenda, Q&A. Participants might deliver your question directly to Dr. Nilam. Please raise your hand before, so the host can set you to unmute, and or you might type your question directly in the chat panel. So anyone want to deliver a question? Yes, there are some students raising their hand. Yes, we start from Liam Roy Marcelino. Yes, you are pleased to
Thank you
deliver your
for
question.
okay. Thank you for the opportunities to give a question. My name is Limroy Marcelino. Or my question is, why do we need statistics in data science? What kind of statistics should I master? Are there any best way to learn statistics, like projects to apply statistic on that or data or something like that?
Okay. We want to collect the question first or answer after the questions, Miss Khadija?
Maybe you can respond directly to each question.
Okay, and thank you very much. Okay, the question is why do we need to have a statistic knowledge lah, right? So if let's say you want to become a data scientist, right, it's actually a combinations of all of the what we call it, all of the knowledge or all of the experience. All right. So statistics, for examples, if you want to do a regressions, right? So in the part of the what we call it, in the regression parts, you need to understand some formula. It's not just simple as the model have been built, but you need to understand the concept. They have a different theory, right? Just for example, statistic included in the part of the what we call it, algorithm of regression. You need to understand how the what we call it, they have a variant multivariates and so on. That's why you need to have that knowledge in order you to understand a little bit more about what actually your target or what actually your output lah for the statistic. It's not just statistic, but you also need to have another area that expertise. For examples, what we call it, in your business, for example, your business domain, you collect all of the data from your business domain, right? So it's not just simple the people or the mathematician and statistic understand, but you need to have also the understanding of your business concept or business perspective, what actually your target, right? It's actually a combination. It's not only the statistic, but a combination for all overall the skills, right? In order you to get a the what we call it, the knowledge about or the expertise about the data scientist. That's all I can what we call it, I can give some response to the why we need to do a statistic in your data science. Is my questions is your questions answering?
Okay, thank you. I'm sorry, my mic was mute, so I need to wait for the host to unmute me.
Okay.
All right. So basically, statistics can be used as a different kind of approach to learn from the data, like that.
Yes.
To add information, like other than from artificial intelligence algorithms or machine learning algorithm, you can use statistics as different
Yes.
kind of approach.
Yes. Yeah.
Okay, so then what kind of statistics should I master then?
What kinds of the statistic?
Like, or are there any best way to learn statistics? Like any projects I can do to apply statistics on them and try to like maybe try to what anyway try to well basically try to see any differences with any other basically any projects to learn statistics.
Okay, there is actually the statistic when you have a data. Right, I try my best to answer. When you have a data, right, this is actually what we call it. You can apply the statistic, the what we call it, the yang keutamaannya adalah you ada data. If let's say you have a data, you can apply anything, either machine learning, either what we call it, either statistic or maybe deep learning. So this is depends on the how the data of you have to how the data looks like lah. If let's say you want to do some forecasting, right, maybe you want to see a correlations of your data, then you can apply a statistic. Right. Commonly lah, when we want to apply a statistic, we want to see a correlations of the data, how the data is correlates between each other. So that's why statistic is applied. If let's say, guys, you want to see how accurate your data, right? Normally statistic include the what we call it, the performance measurements like correlations, like orang kata standard deviation, minimum, maximum error. This is actually a commons of the statistic result lah that we can get. But later on, once you want to see how accurate your data, once you have done statistic, you can use a machine learning algorithm in order you to see how accurate your data. Is it correlates with your data that you have done in the statistic output, in the statistic result. Right, so this is in a many way you can apply either statistic, either machine learning. So my suggestions, every data that you have, you can apply a statistic, right, in order you to get a some output, either standard deviations, either what we call it, the minimum, maximum error. This is a common for the statistician lah. All right. Okay. Is my questions, is your question answered?
I think this is enough. Yes. All right. We can turn to the other student. There are still 3 students raising hand.
Okay.
So maybe kita tampung dulu, and then Dr. Nilam can answer in a summary.
Okay.
Okay. We start
dulu ya.
Yeah, okay. Okay, we start from Farel Gibran. Please deliver your question in short because we have a limited time. Okay. Host, please help Farel to unmute.
Okay, thank you for the opportunity. I've learned little about data science, and at some point I feel overwhelmed with what needs to be learned, such as there are many algorithms for the machine learning. My question is, how do I make learning data science more fun so I can enjoy the learning process more? I think that's from me. Thank you.
All right, thank you, Vania.
Okay, and then we continue to the next student, Fatur Rahman. Host, please help Fatur Rahman to unmute.
Okay, that's I can hear my voice.
Yes, we can hear your voice clearly.
Okay, thank you for the opportunity. So I have a question. My question is how to differentiate the supervised learning and unsupervised learning. Is it just as simple as to see if the data is labeled or not? Or is there another thing or technique to differentiate it? I ask this question because based on my experience, sometimes I got confused with the data that's shown on the paper or journal. That's my question. Thank you.
Thank you.
Okay, thank you. And once more, and I think this is the last because we have a limited time. Please, Alfred Tanov Christian, please, host, help Alfred Tanov to unmute.
Okay. Hello, ma'am. I want to ask something about data science. In data science, wait. So there are some techniques in regression, which is regression logistics and linear regression, and also there's one more thing that I know, which is multilinear regression. Okay. Okay. Ma'am, can you explain to me a little about multilinear regression? Thank you, ma'am.
All right, thank you. All right. Is there any questions, Ms. Khadija?
Yes, Dr. Nilam can give a response to the question.
Okay, I try my best lah to answer, right, for the 3 questions by Faril, Jibrin, Faril, Fatur Rahman, and the last one. All right. Okay, the first one, Faril mentions about how do I make data science more fun? Okay, just my experience lah, for Faril. All right. How do I make data science more fun when I try to started to learn, right? I try to find what is actually the domains that I want to learn. For example, Faril, what is actually interesting for you to, what is actually the interesting topic that you want to learn? For example, you have experience playing a game, right? Mobile game, for example, Dota, or maybe Mobile Legends, right? Or maybe what we call it, anything else that you want to discover. All right. So from here, all right, I try to find out that what is actually the process involved if, let's say, I want to make it the finding of the for example, you playing a game in the Mobile Legends, right? Then you find out that why the process is not accurate, and they're working on the very slow in the slow motions lah in the Mobile Legends. All right. So you think that, oh, I need to have some processing, the what we call it, I need a speed processing to run my what we call it, to run my applications very well. So from here, you're gonna be collect what actually the data, right? You want to see the data that included in the Mobile Legends, for example, any informations lah that related to the Mobile Legends data, right? From here, right, then you can see that, okay, if let's say I want make it my games is more accurate and more what we call it, more intelligence, right? Okay, so you can what we call it, you can try to find out, right, what is actually the model can help you to enhance, to improve your what we call it, your processing times of your Mobile Legends. From here, you can see that, okay, this is very much fun when I found out that, okay, rather than we use for example, you using data decision tree models in my algorithm, I will try to use the support vector machines in order me to get the more accurate in order me to get the more accurate of the processing when I run the Mobile Legend. Right, so this is the starting point lah. All right. For the second question, how to differentiate supervised learning and unsupervised learning. Right, this is actually just a simple. All right, when you want to try to classify, all right, when you try to classify is something like you already have a label, something like you already have a category. So this is what we can set a class supervised learning. But if you notice that your data don't have a label, something like category, then we can classify it unsupervised learning. Just for examples, right? Once in the data, for example, in the CSV file, you already have a structured data, which is a structured well. This is called a supervised learning lah, because they already have a what we call it label data. So either, for example, informations about male and female, the category. Okay, for example, based on the data that we collect, for example, information student, all right, based on the head, based on the what we call it, appearance and so on. This can be category as a male, and another appearance can be category as a female. So this is actually we can classify is a supervised learning. But if let's say you have a data, for examples, like what I can see here, this one, I don't know, this is my vitamin, right? Okay, my vitamin bottles, I seen they have including a lot of color here, right? So when you extract the data, it might be possible the data still not have labeling, right? Because it might be have a slightly orange, right? They have a slightly dark and so on. So this is actually the good way if you want to apply unsupervised learning, in order you to cluster the color in of the bottle. So this is actually the simple way when you want to differentiate lah between what we call it, between supervised and unsupervised learning. All right. The last question, maybe I will try to Nilam, what we call it, try to answer. Right. So multiple linear regression, yeah, if I'm not mistaken, multiple linear regression is actually what we can see is including as the statistical technique that use explanatory variables to predict the outcome, right? It's actually what we can see here, right? The difference between the difference between multilinear regression and linear regression normally is based on the independent variables that you use lah. For linear regression, normally you're going to be use the independent variables, but for the linear regression, you're going to be use multiple regressions, multiple independent variables in your case of the data itself. Right? Okay. Is my answer is menjawab soalan you all?
It is enough. Farel, Fatur Rahman, and Vetranov. Okay, thank you. Okay, Dr. Nilam, actually I have also a question, but the time is limited.
All right.
Is it okay? Or okay. I want to ask about, may you share with us about the topic or subject of data science project that has been developed by a student in UTM, for example, for their final project, maybe behind your supervision?
All right. Okay. Okay. I try to answer the question. Okay. Just for your information, Ms. Khadijah and all, actually, I'm actually conduct the program of business intelligence and analytics for the postgraduate students, right? Whereby in here they have a lot of master project have been done. For examples, in the business intelligence and analytics, most of the students are what we call it, providing some project in the different domain. They choose their own domains, but they apply a machine learning. For examples, stock market predictions using what algorithm? Maybe they use what we call it, regression or for prediction, right? And then my student lah, just hearing for my student project, one of the topics they done using what we call it, plate number detection. This is actually the image or video reconnections lah, video detection. they apply machine learning using XGBoost, right? They apply using CNN, deep learning. So all of these are what we call it, the project using of the machine learning. Another than that is actually they also use my PhD student also working on what we call it biomedical image. All right, they try to identify, they try to classify, enhance the what we call it the blood cell bloods of the leukemia. So they try to find out is this a cancer or not based on the machine learning that they use. Right. That's all that I can share to Ms. Khadijah and all.
Okay, thank you very much, Dr. Nilam, for your explanation, for your answer. And actually, we would like to have more deep discussion about data science today, but unfortunately, we have come to the end of the session. So once again, big thanks to Dr. Nilam for your great and valuable time today. Today is weekend, but you might share your time with us. Thank you very much.
Thank you very much. Thank you very much also for your inviting me. All right, thank you very much also for your faculty inviting me. Hopefully we can meet again face to face lah. Kalau kita ada peluang jumpa.
Okay, maybe in the other opportunity.
Yeah, inshallah.
Okay, and thanks to also thanks to all participants in this room for your attention and participation in this visiting lecturer program. We hope that all we have learned and discussed today will give benefit to us. And on the behalf of moderator in this session, I apologize if there is any mistake in guiding this session. Once again, thank you very much and see you again in the next opportunity. Wassalamualaikum warahmatullahi wabarakatuh. And I back again to Vicky.
All right, thank you very much.
Thank you.
Thank you very much, Dr. Nilam Sjarif and Ms. Khadijah as the moderator. Thank you for the enlightening lecture and for sharing your experience about data science. And as we know, we have gained a lot of new knowledge as a data scientist, the sexiest job in the 21st century. That's quite interesting phrase from our lecturer today. And distinguished guests, ladies and gentlemen, let me continue. For the next session will be break time, guys. So we have now come to the first half of today's event. Participants may leave the event room for break time and be able to rejoin this room at least 1 p.m. So all participants are expected to be back in this room is at 1 p.m. So we hope you enjoy your break time. Thank you for your kind attention and cooperation. See you in the next session.
Terima kasih.
Okay. Terima kasih, Dr. Nilam.
Thank you very much, Dr. Nilam.
Terima kasih. Assalamualaikum.
Waalaikumsalam.
Waalaikumsalam.
Kota Semarang merupakan ibu kota dan kota terbesar di Provinsi Jawa Tengah. Menjadi tempat berdirinya salah satu kampus ternama di Indonesia, Universitas Diponegoro. Universitas Diponegoro bertekad menghasilkan lulusan yang memiliki profil komplit, communicator, professional, leader, educator, dan thinker, yang mampu berkontribusi dalam pengembangan ilmu pengetahuan, teknologi, seni, budaya, dan pendidikan di tingkat nasional dan internasional. Departemen Ilmu Komputer atau Informatika Universitas Diponegoro yang berada di bawah naungan Fakultas Sains dan Matematika menjadi saksi bisu perjuangan.
Halo, selamat siang.
Halo. Hello, Dr. Vania.
Yeah.
Can you hear my voice?
Yeah.
Can we start now?
Iya, coba saya share screen ya. Ini mau pakai bahasa Inggris atau bahasa Indonesia?
This is international program actually, so we hope
Oh,
we can use
okay,
English.
okay, ya. Wait a
Halo,
second.
selamat siang Mbak Clara.
Siang.
Retno. Sorry Mbak. Halo.
Halo.
Ya, Retno, Mbak. Sorry, tadi saya di mute soalnya, jadi pas masuk saya nggak bisa langsung. Say hi.
Oh iya.
Ya.
Enggak.
Belum dimulai ya Pak, saya tak say hi dulu sama Clara.
Oh, okay.
Ya.
Oke.
Gimana kabarnya Mbak?
Baik. Ini oke.
Ya.
Mungkin saya coba share screen ya.
Oh ya, silakan. Nanti dibantu sama Pak Fajar sebagai moderatornya ya Mbak ya. Nanti ada.
Oke.
Ya. Sorry nih ngerepotin.
Enggak apa.
Halo, aku izin masuk semuanya.
Ya,
Izin
dimulai aja.
Oke. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Welcome to the second session of the Visiting Lecture 2022. Before we start, I would like to re-announce some housekeeping notes for today. First, we would like to have your cooperation to mute your microphone in order to avoid any interruption in this meeting. Second, feel free to approach our committee members via meeting chat if you need any assistance. And the third, you may come up with the questions. After the lecture has done, you need to raise your hand and the moderator will give you a chance to turn on your microphone and ask the question. Ladies and gentlemen, for the second session, we are proudly inviting applied scientists from Amazon, UK, Cambridge, Miss Clara Vania, Ph.D. She will be talking about deep learning for natural language programming, past, current, and future. And before we start, I would like to invite the moderator for today's session. He is no other than our lecturer and also a member of the computer graphic lab in our departments. Without further ado, I would like to welcome Mr. Fajar Agung Nugroho, ESCOM MCS. The time is yours.
Thank you. How about now? Yeah, oh, thank you. Dr. Vania is an applied scientist in Amazon Alexa team in Cambridge, UK. Before that, she was a postdoctoral associate at the Machine Learning for Language Center for Data Science, New York University. She got her PhD from the Institute for Language, Cognition and Computation, University of Edinburgh. Dr. Vania has a lot of research interests, but currently she is focusing in the area of natural language understanding and machine learning. She is interested in applying machine learning techniques and exploring linguistic resources to help machine learning models understand the language of the world. So without further ado, please welcome Dr. Vania. Dr. Vania, the screen is yours.
Yeah, thank you. Let me share my screen again. Yeah, can you see my screen all right?
Yes, clearly.
Okay. Yeah. So hi everyone. So thank you for the invitation to give a talk today. So for today I will going to present about deep learning for NLP. So this is probably like a crash course. So like I will explain about like what people do or have been doing in the past. Basically like what kind of models that we use for deep learning for NLP, and then what are we currently using, and then maybe a little bit about like what we can think or we want to think about for the future research in deep learning for NLP. So let me start. So just a short introduction. Basically, natural language processing is a field at the intersection of computer science, linguistics, and artificial intelligence. And recently, with like the rise of deep learning era, basically like this field expand more beyond computer science, linguistics, and artificial intelligence. So we also seen like field from social science, from even mathematics or engineering, physics also can contribute for applications in natural language processing. So the ultimate goal for natural language processing is actually to build a system that can understand human languages. So by understanding human languages, this is not only limited to text, but also basically sometimes also in the spoken languages. So basically understand even like from where we speak. Yeah, so this is like just a illustration. Basically, like currently, I think most of the houses in developed countries now use kind of like personal voice assistant. So you can actually easily buy some things by just like saying to your assistant, for example, like this one, she wants to buy a tissue, but like, yeah, sometimes like there's like misunderstanding whether, yeah, the person said she wants to buy a tissue Kleenex, but the system basically cannot understand what she meant. So yeah, so there are many applications of NLP. So I started with the basic one that probably we use every day. So maybe like most of us use Google a lot. So the first one that we usually do is like basically typing in the search bar, for example, who is the president of Indonesia, and then basically the backend of this, once we type, like there are multiple systems and some of them using NLP technologies. So for example, given this query, basically we want to find documents that are relevant to this question. In the earlier times, maybe like the system is quite simple. Basically, like we index many documents from the web, and then we try to find the document that is most relevant to this query. But nowadays, with the development of technology and also maybe computationally is also like cheaper, we can also introduce a more maybe smarter system using question answering. So basically, like we try to understand first the question, and then from documents, we also try to understand like what the documents, like what are the information in the document, so that we can give like the right answer. So not only like a snippet of document, but really like the correct answer. For example, in this case, Joko Widodo. And then if you look, sometimes you also give like, we are also given like some recommendation. For example, here, if we want to find Joko Widodo, like you can get like some recommendation of like other people that people usually search. And yeah, sometimes if you notice also like there's some like personalization involved. So maybe like the results of my query is different with like the results from another person. Yeah, another application is like text classification, for example. Simply like, so this is, I took this from kompas.com, which is a news site from Indonesia. So like, if you see like there are different topics here. So yeah, ideally like if there are many news reported like each day, like we want to have like a mechanism or automatic system to classify the news into like several topics. And yeah, another one also translation. So this is getting easier now if we don't really speak the language. So say we want to travel somewhere, or we read like a text from another language that we are not native. So yeah, Google Translate also very popular right now. And yeah, so if we look into like the history of the development of this technology, basically like from 2010. So yeah, so maybe around 10 years ago. So there are already like multiple smart assistant developed to give us or to give people like more flexibility or more to help people to have like maybe easier life in terms of helping them. And yeah, so nowadays like there are multiple devices such as from Microsoft we have Cortana, from Apple we have Siri, from Amazon we have Alexa, from Google we have Google Home, and so on. And basically so I just want to mention here that the back end of this application or these devices is basically like almost similar. So first, like as a user, we ask some question, and at the back end, basically there will be a system which is speech recognition that transform our voice question into text. So this is like transforming the raw speech into text. And after that, we need to understand the language. So this component is like natural language understanding. So inside it, like we have natural language processing, of course. And after that, after we understand the question, we have a dialogue management component, which will basically, this can be like system that take as input the question or the right question, and then try to find like the correct answer. So this can be QA system or other possible component. And after we get the right answer, we need a natural language generation. So this is so imagine like the simplest system, probably just like we have a query in terms of SQL and we have a database of say facts information, and then we get the answer, and then to serve this to customer, basically we need to transform the answer into like a natural language text. So we have natural language generation here. And then after that, we also want to return it in speech because we use speech in the device. So here we also have text to speech component, which will transform the speech into text. By the way, if there are any questions, please let me know. Okay, so let's go back to the NLP portion of like this whole system. So first of all, why NLP is hard. So the first big problem is ambiguity. So here a word or a sentence can have multiple meanings. So so I'm using example Indonesian here. So basically like for ambiguity, there are multiple level. The first one is lexical level or word level. So for example, in Indonesia, we have the word beruang, which can mean bear, or which can also mean like having money. Or genting, which can means like the roof, or which can means like it's a very important situation. So if say we have a system like to be able to disambiguate the meaning, basically sometimes it's a bit hard, especially like if this is on question context. Usually we don't have enough context to disambiguate the meaning. So there are multiple models that try to handle this, but like I think the main takeaway here is sometimes we need larger context to be able to know like the exact meaning that actually expressed in the sentence. And similarly, sentence level can also be ambiguous. Here, for example, if I have a sentence, saya makan nasi kemarin, which means I ate rice yesterday. So for example, in Indonesia, like we don't use tenses. So we use kind of another word to reflect when we do the thing, and then basically like this can have different meanings, whether ate the rice yesterday or whether we ate the rice that is cooked yesterday. I think like although they are kind of similar, but they have like different meanings. And this is like a popular one that is used in English. Basically, I saw a man on the hill with a telescope. So the telescope can be with the man. It can be, the telescope can be from the person that is saw the man, and the person that is on the hill can be the man or the other person. So yeah, it's a bit complicated, and sometimes it's hard to disambiguate. If you are just given like this one single sentence, it's a bit hard to disambiguate what actually like the person that wrote this sentence meant. Yeah, so another reason why NLP is hard is the variability. So this is also related to the ambiguity. So here the same meaning can be expressed in multiple ways. So if you want to write a sentence, basically like sometimes you can paraphrase the sentence with different words or with different word orders, for example. So NLP system should also be able to handle like this variability to understand like the exact semantic or meaning of the sentence. And this not only happens within the same language, but this also happen across languages. So if you notice, so there's this like actually like pretty big research area in NLP. So for example, in translation, some languages don't really differentiate gender. So for example, in Indonesia, we don't have gender for pronoun. So if I try Google Translate, even like from yesterday, so if I put so dia here is a pronoun which can refer to a person, and we don't really differentiate between female and male. But if you put this into Google Translate, basically there is a bias there that usually a nurse is a she, and then doctor is a he. So yeah, so this is also another research area that's now is quite a hot topic, because these things is a bit hard, and like languages sometimes can also have like more than two gender. Some languages like Indonesia don't have gender identifier. Yeah, so this is also another problem. Okay, I think. Yeah, I don't know. There should be a figure here. Yeah, maybe I can show this. Yeah, this is also like variability in terms of language. So some languages like Turkish here, so they can use different kinds of word order. So Indonesia, for example, we use a fixed word order like English, where we have like subject, verb, and object, usually the structure. But in some languages like Turkish, we can have different word orders like this. And people that can speak Turkish basically can understand, even though like the word is like have different order like this. And this is because they use some kind of marker in the word itself to mark that this word is actually the object or this word is actually the subject. Okay, let me. Okay. Yeah, and then so in Turkish, basically like this is this is called agglutinative languages, where basically one word can be very, very long because we can add like multiple aspects to the word to mark like some particular grammatical rule. So for example, object, subject, we can add some kind of maybe imperative mark to the word itself. So yeah, processing these languages also becomes a challenging because you can have like multiple words from the same base word, for example. So yeah, so that's like an overview about like the motivation why NLP is important, and then what some of the challenges of like processing languages. And yeah, now let's start with like how we actually process them. So naturally text is sequential. So we know that a word is a sequence of characters, a sentence is a sequence of words, a document is a sequence of sentences. So the question is now, how should we model language? So in NLP, we have a language modeling. So we call it language modeling, which is a central task in NLP. So language modeling have been used for applications such as machine translation, summarization, spell checker, and dialogue systems. And really like the main idea here is we want to model what words comes next given the previous words. So for example, here, again, sorry, this is in Indonesia. Saya harus belajar untuk mempersiapkan ujian, so I need to prepare for my exam. And then there's another word here, and it can be the case that the next word is my exam tomorrow, my final exam, or my linguistic exam, for example. Oke, saya nggak tahu kenapa ini nggak. Kalau saya present kayak, if I present like this, is it okay?
Yes, it's okay, doctor. But we already have your presentation file from Dr. Retno. Can we share it to the audience?
Yeah, sure.
Yeah, so they can zoom in, zoom out as they like.
Or maybe
Because some of
I'll
the texts are very
use
small.
Maybe I'll try using the PDF.
Oh yeah, the PDF version will work, I guess.
Yeah, let me try. Yeah, because this is not.
So can we share your presentation file to the audience?
Yeah, you can share.
Okay.
Can you see it fine now?
Yeah, it's pretty perfect.
Okay, thank you.
Okay.
Sorry about that. Language modeling task is basically the task of assigning the probability of a sentence. So for example, let W0, W2 is basically just a sequence of words in a sentence. So a language model basically computes the probability of W. So W is the sentence as this formulated here. So we want to compute the probability of WT, which is like the current word at like position T, given the previous word in position 0 up to T minus 1. And so this is simply a product of probabilities of individual words, each condition of the history of previous words in the sentence. And even though this simple, actually like this language modeling is used a lot for NLP task or application. And then now I will discuss about maybe like one of the first architecture of language model using neural network. So this is introduced in 2003. So this is the simple feed-forward neural network. So the idea here is pretty simple. So basically for each word, so given a sentence, we have words. And then for each word, we have a table lookup, or now maybe people use embedding. So we first map each word into an embedding, and then we have this TAN-H. So in this, so we fit basically like each embedding and then concatenate them, and then have a nonlinear layer after that. And then after that, we took to predict the next word. Basically, we perform softmax. But yeah, because this is still in 2003, so at that time, like maybe like the computation is not as advanced as now. So basically, like there are many limitations here for this model. So first is like the number of words that we can process at one time is limited. So we cannot really, so ideally, if we want to process a document, for example, we want to process all of the previous word to predict the next word. But yeah, for this architecture, basically we are limited to basically just like previous N words. And then yeah, using softmax. So if you imagine like if we want to predict the next word, it can be any word. And then if our vocabulary is very large, this computation can also be expensive. Yeah, so this is just a simple one that yeah, probably still relevant today because like this is like the first model that is proposed. And then the next one is come word to vec. So the idea is probably similar, but they also propose how to solve the softmax problem. So in their proposed model, basically this is known as CBAU or skip-gram. So yeah, they propose two models at the same time, but essentially like the main idea is the same. So in CBAU, basically we are given, so this is probably not really language model like in the traditional language model because we are given contextual words. So here, if we have T as the position, so we want to predict word at position T, but we are given the surrounding words. So T minus 1, T minus 2, T plus 1, and T plus 2. And then we have embedding layer here to map each word into an embedding. We can sum their embedding and then use it to predict the word in position T. So for skip-gram, it's similar, but it's mirroring. So given like the current word, we want to predict the contextual words surrounding word T. And then for the softmax computation, basically they propose two methods to handle the expensive computation of standard softmax. First is through negative sampling, which is we try to select a small number of kind of negative words that are not correct to update the parameters during training. Or we can also have a hierarchical softmax layer. So hierarchical softmax layers, basically you have several layers of softmax. So we can think about it like, yeah, basically like try to filtering possible target words given given like one word. So it's the softmax is divided into layers in short. Okay, and then yeah, so word2vec and feed-forward neural network use just like a standard multi-layer perceptron. And again, like the limitation of these models, like I said before, is like the number of contextual or number of previous word that we can consider is limited. So around the same time, so this is proposed in 2010. So there is from Mikolov, so they propose a model based on recurrent neural network. So recurrent neural network in practice, they can use infinite amount of context. So the idea here is for each time step. So remember, like for each time step, we want to predict the next word. So we have a kind of like a neural network, which is called RNN. So it computes the hidden step by considering the previous hidden step. So for example, I don't know if I should go detail on the math here, but basically we compute the current hidden states based on the current word embedding and also the previous hidden states. So in this way, we can take into account whatever we have computed before, and essentially we can include like up to like the first word in the history. But yeah, although like in theory this should work, but yeah, in practice, when we try to apply RNN, basically they suffered from long distance dependency. So yeah, they usually just can remember like context of previous words that are closer to the current word, and tend to forget like the words that the distance is very long from the current word. And yeah, just for other information, so there are many variants of RNN. I think yeah, before transformer, which is like the current most popular model, like the most popular one is LSTM. So this is we can think about this as like similar to RNN, but they try to model it such that it can be better in terms of the long distance context. Yeah, so next is a sequence to sequence model. So yeah, so I'm just going through like the variants of model from the beginning up to now. So sequence to sequence model. So the idea here is we still use a sequence of words, but typically like this model is used for text generation. So used for NLP tasks that generate text, for example, machine translation or summarization. Because in machine translation, usually given, say, like a sentence in Indonesian, we want to translate it to English. So here, the architecture usually called sequence to sequence or encoder-decoder architecture, where the encoder basically responsible to transfer raw input into a hidden representation. And then the decoder is responsible to generate output from a hidden representation. So just short example here. So this is the earlier model that is used or proposed for machine translation. So if we have a sequence of words x1 up to xt, basically we can have a sequence. So H is basically hidden states, and we can have bidirectional RNN or bidirectional LSTM here to encode the input. And then we can compute a representation here. So this is using called as attention mechanism. And then basically like this up to this point, like we have a hidden representation, and we can use this to generate the next word. So this is like the output level. So we want to generate a word at position T, for example. So because this is also using RNN or LSTM basically to compute or to predict the word at position T, we use the information from input, but we also use the information from the previous generated word. Yeah, and then yeah, if some people here are not familiar with attention mechanism, so there are multiple ways to perform attention mechanism. But the main idea of attention mechanism is that we want to give different weights, or we call it attention, to different input. Yeah, so for example, here, these are the attention. So for example, when we want to predict or generate the word at position T, maybe X3 is more informative because X3 is basically the translation of YT. So we want to attend more to X3 rather than other input words. But maybe other input words, there are some that quite relevant to the translated output. So we also want to give some attention, or maybe like a little more attention to some other words. Okay. So this is quite fast. Basically, like from the feed-forward RNN LSTM and then sequence-to-sequence model, and then around 2017. So there is this paper, I think, from Google, which happens to be quite big. So this paper called "Attention is All You Need." So they proposed transformer model, which is now very popularly used in multiple models in NLP. So here, the idea is it is non-recurrent. So remember before is recurrent neural network. I think it's recurrent because whenever we at position T, we take into account the hidden states we compute from the previous T-1. So for this model, they propose non-recurrent, and then because of this, basically, long distance context has equal opportunity, meaning that if I'm at position T, like I can give attention at word in position T -1 and position 0 with the same attention. So we can learn basically attention, and then they have like equal opportunity. And another advantage of this model is it allows parallelization. So because we don't need to wait to process the full history, we can process each word in the previous history at the same time. And yeah, I think the components are a bit complicated here, but they have multi-headed self-attention, feed-forward layers, layer norm, and residuals, and positional encoding. So I included complete explanations here. Yeah, I think it needs like several hours to understand this. But yeah, the main idea here is maybe with this visualization is clearer. So basically, like for usually we encode like input words into a hidden representation, and then in this architecture, basically we have several layers. It can be up to 12 layers. And in each layer, basically, for example, if this is the first layer, this is the second layer. In the second layer, we have multiple head attention. So we have different attention. This color scheme basically represent different attention. So in their paper, basically they show that when they process this for language modeling tasks, there are some head that maybe learn something relevant to the object, or something relevant to the subject, or something relevant to like the explanation of the word. So for example, here there's making, and then we see here the thin or the thick lines here represents like the attention. So maybe here we see that for the word making, there are some head, which is a hidden representation, that attend to other words in the input, which probably can support this particular word. So making is supported by more difficult, for example, and what we are making. So there is some attention to the word laws here, and to the year when this law is made, for example. Yeah, so basically like this architecture is quite big, but essentially like the idea here is we have several layers, and each layer, for each input word, we have multi-head attention, that each head usually, or we expect that each head will learn some particular aspect of the language for that particular word. Okay, yeah, so that's basically the main idea for transformer model. And yeah, after the transformer model, basically for NLP, we know there's a model called BERT. So this is bidirectional encoder representation from transformer. And yeah, this is, I think, still used currently for NLP task. Yeah, even though like there are many more recent models now. So here they use the transformer model, but it is also used in bidirectional way. So bidirectional means that given a sequence of words in the sentence, we process them in like two ways, so going forward and going backward. So the reason of this is the reason that language understanding is bidirectional. So this is a bit different with language modeling assumption. So in language modeling, the traditional assumption is we always want to predict the next word. So we only have context from previous history. But in this case, if we want to have a model that can understand the meaning of a sentence, we need to have context for the whole sentence. So this is why they use the bidirectional in their architecture. And to train this model, so they use transformer architecture, and then to train this model, they use 2 pre-training tasks. So the first, they call this as mask language model. So the main idea here is given a list of words in the sentence, we mask out K%. So in their paper, they use 15% of the input words, and then train a bidirectional encoder to predict the mask words. So for example, here, if we have the dog wants to go to London to meet his friends, we can mask these 2 words. So this is chosen randomly. And then we train the model to predict the mask word. So this is the pre-training task number 1. Pre-training task number 2 is next sentence prediction. So they fit the model with 2 sentences, sentence A and sentence B. And then the task is to predict whether sentence B is the actual sentence that follows sentence A. So yeah, maybe using this is a bit clearer. So this is the pre-training task. So given, so this is mask sentence A and mask sentence B. So this is the next sentence prediction. So basically we fit the model with 2 sentences. There is a CLS token here, which usually use to represent the whole input. And then sub here is just another special token to separate between the 2 inputs. And then each sentence also mask 15%. So we have the tokens, we have some special tokens. We transform them into an embeddings, and actually like these embeddings also, they have word embeddings, they have position embeddings, so they also need to take into account the position of the word, because remember, like we don't use recurrent neural network again now, so we don't really track the position, so we need to embed the position as well. And then this basically like just a layer of transformer model. And we want to predict the mask words, and also we want to predict next sentence prediction. So for next sentence prediction, usually we just use the CLS token at the last layer, because the CLS token, we assume that it summarizes the whole input. So yeah, I think after the introduction of BERT, like the way we train models for NLP tasks is now different. So usually like we start with a model that is pre-trained using lots of data, because essentially like to train this model, you just need raw text. You don't need like annotation. You don't need like labels, because the label itself is in the sentence. So yeah, so usually like now people just like use available pre-trained models such as BERT, and then you fine-tune the model. So you fine-tune the parameters here so that it can learn like specific tasks. So for example, these are like some popular tasks in NLP. So MNLI, name entity recognition, MNLI is natural language inference, SQUAD is a question answering dataset. And yeah, basically like to be able to fine-tune these tasks, you just need to add like another layer. So for example, if it is a classification layer, you can use like the CLS token, and then so it is a hidden representation, right? So you can use, for example, if it is 3-way classification, you can just use softmax over 3 classes. Yeah, for question answering, there are multiple formats, but yeah, essentially like the process is the same. So you use pre-trained model and then fine-tune on your target task. So this is another popular generative pre-training transformer, or usually people call it GPT. So now it's up to GPT-3, I think. So the main difference with BERT is it is generative model. So it's, or people maybe usually call it autoregressive model. So this using transformer model, but the main architecture is still following the traditional language model. So it's like going step by step, and only for each position T, we can only use the context from previous history, so not bidirectional. And yeah, so for training this model, maybe I'll go to the next slide. So maybe this is clearer, like the difference between BERT and a GPT model. So Elmo is like another older model before BERT, but yeah, I won't discuss it in detail today. But the main difference between BERT and OpenAI is BERT is bidirectional. So you can see here, like at position second here, we get attention from different input words, even from the last word. But for GPT, basically like it's autoregressive. So at position 2 here, I can only get input from access here and I here. So there is no connection between this hidden state with account, for example. Yeah, so GPT is trained like this. And if we want to use it for some particular task, basically it's the same. So we have multiple layers, and then depending on your task, so for example, classification, we can just use the CLS token again, and then have a linear layer to predict the class. So this is just like some variation regarding the task format. So yeah, in NLP we have like entailment tasks, which is to predict whether like one sentence entail another sentence, similarity given to sentence. So this is kind of like paraphrase model. We want to predict whether one sentence is a paraphrase of another sentence. Multiple choice. Yeah, so this is a bit interesting because like the way we solve this is, so usually this is used for question answering. So we have a question, we have several choices for answer. So the way we use BERT or GPT model to answer this is basically we concatenate the context and the answer option. So context here can be a question, for example. We concatenate it with the answer, and then we use a delimiter like SAP token in BERT. And then we run this through several layers. We have the last hidden state. We pass it to a linear layer here, and then basically we can process them by pulling or something like that to get like what is the most probable answer given the context. Yeah, so yeah, this is BERT and GPT model. I think essentially like after GPT and BERT, like there are many models which I won't explain one by one here. But as we see here, like this is from Elmo, which is proposed 2018, and then comes GPT, and then comes BERT. Like the most recent model, usually like the number of parameters getting more and more. So for example, the GPT-3 model, which is the latest one from GPT family, they have like 175 billion parameters. So this is like 2020. Yeah, I'm not really up to date with the most recent one from other research lab, to be honest. But yeah, I think part of the reason why this is getting bigger and bigger, because I think usually in NLP and maybe like other research field like computer vision, like we usually use like some usually popular set for benchmark tasks, and then we evaluate our model on those benchmark tasks. And so far it has been shown that like when we increase the number of parameters and model size of the pre-trained models, like we can get like better performance. So yeah, this, I think like there is pro and cons here, because maybe the positive side is like we can have a better model which probably include all the knowledge that we know in the world from text, but at the same time it's a bit hard like for like maybe smaller research lab to work using this model, or even it's impossible to train like this model. Only like few labs can train this kind of pre-trained model. And also in terms of deployment, when we want to use this model in production, for example, it is hard because like the larger the model, it will increase the latency to process the process data using this model, and also yeah, the basically like the model deployment in production can be challenging. Yeah, so yeah, I think that's the first part that I want to touch on regarding basically like large language models that are now used in NLP. Next, I will discuss about transfer learning, but before that, if there are some questions, maybe I can take some.
Oh yeah, if you prefer to have question at this moment, we can ask from the audience if they're common students. This is a rare opportunity. If you have some question, you can always raise hands. But can you move back to slide number 11?
Okay.
Dr. Clara?
Okay. Yeah.
This formula is very straightforward, I guess. I think.
Yeah.
So this is trying to predict the word given other word, isn't it?
Yeah, yeah.
But in my basic understanding in predicting of a word, I guess the position of the word that is going to be predicted is also important to be included in the parameter, isn't it? Don't you think so?
Yeah. So this one, I think, yeah, the first basic model, even before like neural network model, like we take into account the position, because yeah, so it is called like n-gram language model. So n basically like how many words before that we consider, and yeah, basically in practice what we need to do is just like count the number of times this word occur with like, so say like I want to use 2 grams, so I just check like if I say I read X, so we want to predict X, like I will check like what other 2 words that occur in the a corpus or a document or larger set of corpus that occur before the word book, for example. So maybe I read book, she borrow book, something like. So we count like the phrase in like these 2 grams. So in that case, like we also take into account like the order of the previous words.
Oh yeah, but this model
Yeah. So if you
is this
imagine like
still being
I
used?
just have, sorry.
Is this model is still being used?
Maybe not really anymore, but I think like the basic idea
Yeah.
is the same that is used
Yeah,
for
I
like
guess so.
current modern model. Yeah.
Okay,
But
thank
and
you.
also maybe for some low resource languages where we don't have large pre-trained models, this is also still be used.
Yeah. But the language always growing, so the model also have to catch up, right?
Yeah.
Do we have question? Oh, not yet. Maybe the topic is too
Okay.
hard.
Okay. Yeah, I can continue and then we can.
Oh, I still have one more, if you allow.
Yeah.
Can you move to slide 17? 16.
Okay.
On this diagram, on the decoder part, on the bottom of it, I see outputs, but it's actually input. I don't understand it in this part. Where did it come from?
So this is actually like just maybe like one way to do this. So if you remember, like if we have the sequence to sequence model like this, so we have input from the hidden representation and also the previous generated output. Because because on the decoder side, so say like I want to translate from Indonesian to English. When I translate the next English word, I also want to take into account what I generated before, like before the current position, because yeah, we also want to generate like natural language, so we want like the generated output to be grammatically correct, for example. So I don't want to generate, for example, what is the example here? Like
You can use Bahasa Indonesia as an example to make it more
for example,
clear
like
to the audience.
No, for example, if I want to translate saya membaca buku itu to I read that book, for example, after say like we have generated I read that, and then we want to generate book in this example. So say when we are at position, is it T here, like we want to be able to have the previous context that we have generated read. So it's nonsensical or it's impossible that I use something like I read that pizza, for example, because so previously like I generate read, so I need to generate word that relevant to read and not like other things, for example. So I think the idea of this encoder decoder model is the same. So we can input the previous output that we generated as input to the decoder to output something here.
Yeah, so it's not just relying on the word that is going to be translated, but also considering the word T-1. Isn't it? If I'm correct.
Yeah, the previous word, but on the output layer.
But the caption is shifted right. If the previous, in my imagination, I'm not an LP person. Imagination, the previous word should be on the left side, but why this is shifted to the right?
Shifted right means that you just move it one. So how to explain? Like, so if I have I read the book, I read the as like previous output.
Yeah.
I shifted it to the right one step. So now
to process the other.
To process the next output. Yeah. So the previous word basically becomes the input for the current step.
Oh, okay. Yeah, I see now.
Yeah, but this is like, again, like we can do anything we want. Basically, I think the BERT model, they don't use output embedding, I think, because like, because it's not encoder I mean, this decoder term also a bit ambiguous, because if you just have like one classification layer is also a decoder actually, but in the BERT architecture, it's not really generating something. So we can skip to fit like the output embedding, and then just like process basically like whatever the last layer of the encoder we have, and then output something.
Oh, yeah. I see now.
Yeah. Should I go continue?
Yeah, we still
Mr.
don't have.
Sorry.
Oh, yeah. Please, Dr. Retno.
May I ask a question to Clara in Bahasa Indonesia to make it clear?
Okay.
Of course.
Because I have a question, but I think it will be clear for me or maybe for some student with Bahasa Indonesia.
Okay.
Yes, please.
Ya, Clara. Di salah satu slide dikatakan bahwasanya language model yang sudah dikembangkan itu kan dari berbagai laboratori gitu ya, sudah bermacam-macam ya, mulai dari BERT, lalu ada GPT dan seterusnya gitu ya, yang mana sebenarnya kan language dependent ya,
Language, iya, language dependent ya.
Okay. Language dependent. Nah,
Uh-huh.
Yang kita tahu versi dalam bahasa Indonesia kan yang sudah ada bird ya, bird
Iya.
dengan Indobird-nya gitu.
Uh-huh.
Nah, apakah sesuatu yang krusial gitu ya untuk kita misalnya doing hal yang sama seperti Indobird tapi dengan misalnya model-model yang lain, atau sebenarnya everything solved with Indobird, tinggal bagaimana selanjutnya kita mau melakukan tas apapun, nah itu masalah di depannya yang diselesaikan. Menurut Clara gimana?
Iya, jadi ya jadi kayaknya saya jawab bahasa Indonesia aja ya.
Yeah.
Jadi sepertinya sih menurut saya sampai saat ini masih belum begitu jelas ya apakah menggunakan kayak bird model spesifik, jadi cuman di train pakai bahasa Indonesia itu lebih baik atau enggak daripada pakai katakan Ambert, because karena Ambert itu kan multilingual bird, dia juga di-train di berbagai bahasa termasuk bahasa Indonesia. Jadi ada beberapa faktor di sini ya. Jadi pertama mungkin size dari training data untuk bahasa tersebut. Apakah di multilingual bird itu size training datanya cukup banyak atau enggak. Jadi ada beberapa grup, misalkan ya yang saya tahu ya mungkin buat bahasa French ya. Jadi mereka punya berbagai macam bird model, jadi di train khusus di teks bahasa Prancis. Mungkin mereka trainnya ya lagi-lagi tergantung size dari training datanya, mungkin training datanya lebih bersih daripada yang dipakai di Ambert. Jadi berbagai faktor itu bisa mempengaruhi sih. Kalau misalkan kita bisa train dengan lebih banyak data dan datanya lebih bersih, mungkin ya. Jadi ya saya nggak tahu, kayaknya beberapa model bisa pakai training data dari Reddit atau forum yang lumayan noisy. Jadi kalau kita bisa training spesifik model pakai cleaner dataset dengan size yang cukup, mungkin itu bisa lebih baik daripada pakai multilingual bird. Tapi untuk beberapa bahasa lain, ya saya lupa sih apakah ada bahasa Jawa di multilingual bird. Misalkan kita nggak punya banyak raw text atau dokumen tertulis di bahasa tersebut, kita cuma punya sedikit, mungkin pakai multilingual bird bisa lebih baik karena ada somehow ada transfer learning dari bahasa lain ke bahasa tersebut. Tapi ini juga case by case ya. Ya misalkan aja kalau saya pikir, misalkan nih bahasa Indonesia nggak begitu banyak atau bahasa Malaysia nggak begitu banyak, tapi kita sharing vocabulary dengan bahasa Malaysia. Jadi kalau misalkan salah satu dari bahasa ini kita nggak punya banyak training data, mungkin lumayan bermanfaat, atau ya ekspektasi saya performance-nya bakal lebih baik kalau kita train dua bahasa ini bersamaan, karena ibaratnya knowledge dari bahasa yang lebih high resource itu bisa kita manfaatkan untuk bahasa yang low resource. Ya, nggak tahu ini menjawab apa enggak. Tapi kalau khususnya buat bahasa Indonesia sih, menurut saya sekarang resource-nya udah lumayan banyak ya, dan setahu saya udah banyak sekali researcher lain, ya kebanyakan orang Indonesia yang sekarang propose model, pre-train model untuk bahasa Indonesia, bahkan setahu saya ada yang pakai Twitter. Jadi kalau ada yang mau riset tentang sosial media mungkin lumayan ya bermanfaat, bisa dicoba, dan itu ada di Hugging Face kayaknya. Dan ya dataset juga ada cukup beberapa sekarang untuk berbagai macam task NLP. Ya, jadi itu sekarang lagi banyak dikembangkan sih kayaknya.
Hugging Face buat Twitter sudah ada ya?
Hugging Face untuk Twitter? Iya, kayaknya udah ada deh. Iya. kayaknya tinggal cari di dataset atau di modelnya Indo gitu ya. Kayak akan banyak keluar, ada Indobird, bahkan Indobird ada dua, soalnya ada dua grup yang propose dalam waktu yang bersamaan, jadi ada dua varian model. Terus ya salah satu yang propose Indobird itu juga propose pakai jadi trainnya pakai Twitter data. Ya.
Ya, Oke, kalau Tweetbird, Indobird saya tahu, kalau yang tweet Hugging Face saya yang tahu.
Oke.
Thank you.
Iya. Oke. Yeah. Maybe should I continue?
Yes,
Yes, of course.
Okay. Yeah. So now I will go into transfer learning with large language models. So again, like I won't go into much details, but just like go through like several ways how we can use transfer learning with these large language models. Yeah, so the basic idea of transfer learning is basically we want to use the knowledge stored or learned when we solve one problem to help another related problem. So yeah, the basic transfer learning here, maybe like you can guess, like since the large language models like BERT were trained on massive amount of data, so we can use you can utilize their knowledge for specific target tasks. And in fact, like this is how we currently using it. So we use pre-trained models and then we fine-tune it for our target task. And this is especially useful for target tasks where we have limited or zero label data. And I will discuss this a bit more next. So yeah, so one way to do transfer learning is through intermediate task transfer. So the idea is very simple here. So first we use a pre-trained model on unlabeled data such as BERT or Roberta. So Roberta is another variant of BERT, which is trained a bit better than BERT. So they have a better quality. And then the idea of intermediate task transfer is first we fine-tune it. We fine-tune the model on a large labeled intermediate data set. So how we choose the intermediate data set? So we usually choose it based on, yeah, it can be heuristic, it can be like intuition or empirical experiment, but usually we can use tasks that we think it will be helpful for the target task where we don't have like much label data. So for example, what is the example here? So for example, we can have target tasks such as question answering, for example. Maybe identifying the entity in the sentence will be helpful for question answering. So we can try fine-tune the pre-trained model on name entity recognition task, for example, and then after that we fine-tune it again for the question answering task. So this is like a very straightforward strategy to perform transfer learning. And yeah, this is a work from my previous group. Basically, like we try to experiment with various, we call it intermediate tasks, to find like which one basically help for the target task. So yeah, so this is basically like the rows here are target tasks. So yeah, maybe if you are not familiar, some of these are question answering tasks. Some are entailment tasks. So entailment tasks basically like if one sentence entail another sentence, or if given one sentence, can you say that the sentence is correct given the other sentence? Yeah, so we perform like large scale experiments here by trying to train the model using this intermediate task here and measure the performance for the target task. And what we find here is basically blue, we get like some improvement, red, we get like, lower performance, while when we fine tune on the intermediate task, and we find that for tasks that we use here, basically the common sense related tasks such as common sense QA, basically a question answering data set related to common sense, Cosmos QA and HELA Swag are quite useful to help some of these target tasks. And we apply like the same thing for transfer across languages. So this is English intermediate task training. This is for zero-shot cross-lingual transfer. So the idea here is we have target task in different language, so in non-English language, and then we don't have any label data in that language for the target task. So how we can improve it using English intermediate task? So the main idea here is we use a pre-trained model that is trained using multilingual text. So this is XLMR, so one of the pre-trained model. And then we can perform intermediate task training in English. So say like our target task is question answering in Indonesia. So we can do intermediate task training using one or several QA dataset in English. Oh, sorry, maybe intermediate task is different with the target task. So say target task is QA, intermediate task is say like the textual entailment. So intermediate task, we can train it using entailment dataset like NLI, natural language inference dataset in English. And then say we also have the target task, so QA task in English dataset. So we can fine tune it again using English QA dataset. And then we evaluate basically directly in Indonesian for question answering. So this is the scenario where we have zero-shot cross-lingual transfer. And again, we perform large-scale experiments, but yeah, the result is a bit mixed. So this is the column here is the target task. The rows here are intermediate task. So basically what we find here is SQUAD, which is question answering dataset, is quite helpful for zero-shot cross-lingual transfer for other QA tasks. And the one that we find the best is if we perform multitask training. So basically like we have a set of intermediate tasks and then we train them together during intermediate task training. We get the best performance on the target task. So on average, we get 8.7 improvement. And then more detail can be seen in the paper, but I just want to highlight like this is also possible. So that is like one way, intermediate task training. The second way is through multitask learning. So multitask learning, I discussed a little bit before. Basically, the idea is we train multiple tasks together at the same time. So there is this new model. This is proposed in 2020. So previously, when we perform multitask learning, there is one limitation, which is like whenever we have a model, if we want to perform multitask learning or multitask training, we need to have all the tasks to have the same format. So for example, I think usually people just, if it is trained for text classification 10 class, it will be like the same architecture, so the same task of text classification, so that we can use the same architecture. But we cannot really mix up, say, question answering with text classification task. So in 2020, basically, there is this new model, T5, which, the parameters also, I think, 11 billion or something. So they propose multitask learning that can go beyond different task format. And the basic idea is here, T5 is transformer-based model, but it is set up with encoder-decoder architecture. So the decoder basically generates the answer. So they combine multiple tasks. So this one, I think, one color, basically one task. So for example, this is machine translation task. And then we kind of like give a prompt or give a task definition to the model. So for example, translate English to German, that is good. So this is the input, and the output is basically like the translation. And then, yeah, maybe this is very specific, the red and the yellow specific task. Maybe like the blue one is easier here. So summarization, for example. So summarize this, and then the output is basically the summarization of the text. So we basically reformat all tasks with this sequence to sequence output generation. But yeah, so maybe like the green one and blue one are like clear. This is like language generation task. The yellow one, for example, I think this is sentence similarity dataset. So we have two sentences here. The rhino grazed on the grass, and then sentence 2, a rhino is grazing in the field. And I think this task, you need to compute the similarity between these two sentences. So usually people will have probably, yeah, maybe linear layer and then output like sentence similarity score, or using like some kind of metric to perform the similarity. But now this model is trained to generate the similarity score. So this is also like generated output. This one classification, I think the output is just acceptable or not acceptable. So usually we just use a linear layer to classify between these two labels, but when training this model, they reformat the task so that like the outputs, the model needs to generate the text itself, so not acceptable or acceptable. Yeah, so this is like another model that is quite popular right now. And they train it using like multiple tasks, so we can also perform zero-shot transfer using this model. Because what you want to give to the model is basically just the task definition. And yeah, I think like some tasks is a bit similar with some tasks that they train on, so people can do transfer learning using this model. Next is few-shot learning. So few-shot learning is, the idea here is we only have very few labeled example. So yeah, if people are interested, I put the link here, basically like full tutorial about few-shot learning in NLP. But basically like the traditional few-shot learning, usually we have N-way K-shot learning. So the situation is during training, for example, we have two classes, and then we train the model to predict these two classes. And during testing, basically, we have additional classes that we don't see during training. And for the new classes, we only have very few examples. So N-way K-shot learning means that N is the number of class. So for example, here we have two classes, the green and the yellow. K refers to the number of examples for each class, which in this case also 2. And the main idea here, given these examples at test time, we need to find a way so that the model can also classify into these new classes. And then there are multiple methods to do this. So yeah, I think usually people can perform fine tuning, but because we only have very few example, usually if you have model like BERT model, you can freeze like most of the parameters of BERT and only like fine tune like maybe the output layer for the new classes, because we don't have like that many examples. Some other methods also perform K nearest neighbor. So K nearest neighbor, basically the idea is you compute the hidden representation and then you perform K nearest neighbor to the closest class embedding. And there are many methods now looking into meta learning. Yeah, to be honest, I'm not an expert on this, but yeah, I think it also has a bit of mixed results. Like some people have like positive results, but some also have like not really good results. So it's not clear whether like meta learning can be successful for few-shot learning. And then the modern way to do few-shot learning. So yeah, I think this is specific for NLP. So the scenario is still the same. So we have training data here with 2 classes. And during testing, basically, we have again like a few examples, and we can use the task description. So maybe if you notice, like this is kind of similar with the setup of the T5. So we can also give the model to about the task description, and then somehow ask the model to predict the right class. So for example, this is usually used for GPT model. So yeah, they call it in context learning. So in context learning, basically, we somehow perform few shot learning, but we don't really update the model parameter. And so there is this, so there is no task specific parameter in this case. So for example, for movie review dataset, so maybe like the input is the sentence containing opinions about the movie, and the label is positive or negative. So say like we want to use GPT-3, which again, like trained for language modeling task, so it's not trained for movie review. So the idea here is we give the model some examples like this. So if we have like, say, examples about the positive and negative, so people call it prompt. So we prompt the model using these 2 examples. So just concatenate the sentence with the sentiment here. So it was great, maybe it's like positive, it was terrible, it is negative. So yeah, again, this is just using language model. So we give the first training input and output, second training input and output, and maybe another another sentence. So this sentence is basically the one that we want to predict the sentiment. So we compute the probability of generating it was great and compare it with the probability of generating it was terrible. And if say the probability of P1 is larger than P2, we say that the sentiment is positive. If probability P1 is less than P2, we say that the label is negative. So yeah, this is one way that people now use GPT-3 for. So it's called context learning, because even though we don't like update the parameters, somehow like the model can follow because it uses the previous context to generate the next word. And this is the in context learning results for superglue. So superglue basically like a benchmark that is used. So it contains like a set of NLP tasks for like different tasks, and usually used to benchmark models. So if you see here, the comparison between 0 shot, 1 shot, and few shot. So few shot here, like K is equal to 32. We can see here that, yeah, so the x-axis here is the number of parameters, billions of parameters in language model, and this is the superglue score. So they compare this 0 shot, 1 shot, and few shots. So 1 shot is just using one example, few shot is using 32. Basically, the few shot and I think 1 shot here is quite comparable with the model if we use fine-tuned BERT. So this is I think supervised, so fully supervised using training data. So I think like when we use like very large model, basically we can have comparable results with a fine-tuned BERT model. So another way to perform few shot learning is call it prompt-based fine-tuning. So different with the in context learning, basically this method is using gradient update. So we fine-tune the model, and then yeah, because we perform gradient update, so the parameter change. So we have like task-specific parameters here. So the idea here is like, if we see on the left here, the standard fine-tuning. So we have input, 3-hour cinema masterclass, and then we feed it to BERT or some other large language models, and then we have classification head to predict positive and negative. So the idea here is like we combine the prompting with fine tuning. So we fit the original sentence, it was, and then we have a mass token here. And remember, like BERT is trying to predict mass token. So we fit into BERT, and then we compute or we compare the probability of predicting great versus the probability of predicting terrible. So in this case, like you can, yeah, basically like you can reformat the task of like this movie review into like, yeah, predicting the mass token task. Yeah, so that is like what we do for few-shot learning, but like there are many challenges still there. Basically, like what people have found is using this prompt learning or in context learning, the results is very, very sensitive into the choices that you make for the prompting. So for example, what examples you use for prompting the model. For example, in context learning, you can, yeah, if you have like some small label data set, you can use it. You can also, if it's very few shot learning, like say 3 shot, you can also manually create the examples. But how you create the examples is like, yeah, the result is very dependent on like how you use the examples, how you order the examples, and also like the prompt selection. So yeah, there is a big research area also here. Basically like how we select the right prompt. So previously we just used like prompt, it was something. But yeah, people now using like various ways to create prompts for not only classification, but also question answering, for example. And then, yeah, even like there is like some groups that I think try to generate prompt using model. So finding like the most, most good prompt, like the best prompt for a specific task, for example. Yeah, so that is for few shot learning. And yeah, the last one I want to touch a bit is a zero shot learning. So zero shot learning here, I think like there are many ways, but like, yeah, I want to discuss like two most popular ones that people use. So the case one is if we want to perform zero shot learning on the same language. So what we can do here is basically we can reformat the target task as the source task. So for example, here, say we have a target task, which is relation extraction. So relation extraction is a task to extract relation given a sentence with simplest one is 2 entities. So for example, if we have a sentence here, Joko Widodo terpilih sebagai Presiden Republik Indonesia pada pemilihan presiden 2014. Jadi, so Joko Widodo is chosen as the President of Indonesia at 2014, and then we want to extract that the label is president. So the relation between Joko Widodo and Indonesia that is expressed in the sentence is president. And say like to train RE model, basically we need like labeled data, like multiple sentences between entities, and then the sentence basically express the relation. And then typically like this involve human annotation, which can be expensive. So one way to do this is, for example, we have available natural language inference or textual entailment dataset. So the way this work is we are given 2 sentences. One is premise, second is hypothesis. And we ask the model whether the premise entails the hypothesis, or if the hypothesis is correct given the premise. So say like for the relation extraction task, we don't have like any labeled data, but for NLI tasks, we have some labeled data. Yeah, so for example, like this NLI, we have Indonesian data set, which me and some colleagues created, if you're interested. So yeah, so say like we have NLI data set in Indonesian, and then we can fine tune BERT model using this data set. So if we want to perform RE, for example, one way to do this is we can reformat the task. So for the premise, we use the original sentence. For the hypothesis, we can create the sentence by yeah, usually currently just using templates. So if we have Joko Widodo and Indonesia, and one of the possible relation between a person and a country is a president, so we can create a hypothesis sentence. Joko Widodo adalah Presiden Negara Indonesia, Joko Widodo is the President of Indonesia, and ask the model to label this premise hypothesis pair, whether entailment or not entailment. And yeah, so this reformatting task is actually one successful case that is, yeah, so I put the paper here. Basically, they reformat the relation extraction task as natural language inference task. And yeah, I think they have like good results in terms of when they perform it 0 shot, few shot, or fully supervised setup. Yeah, and then that is one scenario. So when the source task and target tasks are in the same language. Another scenario is like when the source language different with the target language. So I think like, yeah, the advantage, like maybe the most advantage of like having multilingual large language models now is that we can perform 0 shot learning in languages that before we cannot perform any, like even 0 shot learning. So yeah, the idea is, yeah, maybe you can guess, like basically we use multilingual language model as pre-trained model, and then we fine tune on high resource language labeled data, and then evaluate on target language data. So this is the standard setup that people usually use. Optionally, you can also use machine translation if it is available. I think, yeah, for machine translation, there is one group called Opus, so OPUS, that they, I think, release model in like many language pair. Of course, like the quality depends on like the number of data set that they use to train the model. But one way to do 0 shot learning, also some people, if there is available machine translation model, they either train the they either translate the training data. So say like I only have training data in English, but I want to evaluate on it in Indonesian. Like I can translate the training data into Indonesian and then fine tuning on the translated data. Another way is translate the test data. So we can use the English training data, and then for the test data, we translate the Indonesian evaluation data into English. But again, like the challenges here is like, first, multilingual language model pre-training data might contain very little. So this is relevant to, I think Baruno asked before. So yeah, the multilingual pre-training data might contain very little to no data in low resource languages. And then the performance, if we want to use machine translation model, is like very depending on like the quality of the machine translation model. So what's next after this? So I think like, maybe NLP is like a bit hot and crowded area at the moment. I think there are some people that or like big research group that focus on like building like this larger scale model for like maybe better to support like better training for like downstream tasks. But also like I think like there is some avenue on like having a lightweight or more efficient model. So there are also quite lots of works now on knowledge distillation. So the main idea here is I think teacher-student model. So you have like very large model, but you want to distill the knowledge in this large model to a smaller model that is more lightweight. So it may be like more useful when you deploy it for application or something like that. So this is also quite useful, I think. And then parameter efficient model training. So there are also works that try to, basically you start to with large model, but during training you start pruning some of the parameters. So at the end you have smaller model. So yeah, I think that's also some venue around lightweight or more efficient model. Another thing is like learning from limited label data. So I think for English, I think it's quite high resource, but like for other languages, especially, yeah, we still have very limited label data. So I think in this case, like how we can, yeah, given these large language models, how we can perform better using few shot learning, or maybe like some efficient data collection if we have limited budget for creating data set, because creating data set you need yeah, lots of budget. So how we can build like more efficient way to collect data so that we have maybe like smaller labeled data, but it is useful during training. Yeah, I think, yeah, for multilingual here also, like yeah, I think there are now multiple works on creating benchmark data sets. I think it's getting more and more now for low resource languages. Yeah, I think, yeah, if people are interested, I think now is a good time, because I think it's like unlike before, I think it's getting more attention now if we propose like new data sets for like other languages. And yeah, I think the other one, if like on the modeling side, usually people just use whatever pre-trained models available out there, like MBERT or XLMR, for example. But there are still like many open questions regarding like the right pre-training methods and data selection. Should we use like all models, all languages, for example, and then train a single model, or maybe just like train a model with training data from languages that probably closer together. Yeah, so I think like there are still like open questions around this area as well. Yeah, I think this is my last slide. I think if, yeah, there are any questions.
Okay, Dr. Vania, thank you for your presentation. It was amazing. Once again, to all our students here, please participate this program by giving a question, and don't get what we call it. Don't get it's I mean by Dr. Retno's question was really advanced, so maybe the students getting, what's the correct expression, intimidated. Yeah.
Yeah.
It's always okay to give a simple question or even silly one. Perhaps I have to give an example of that.
Yeah.
Dr. Vania, can you go back to slide number 17?
17, okay.
Yeah, in here we have a strong correlation. Can we say the expression of correlation? From
Yeah.
the word making into more and difficult. How can we know that more should be the earlier and the other way around, difficult is the later? How can we
Right. Yeah, so I didn't explain this in the details, but actually like in transformer architecture, like for the input, we also encode the position of the word, because unlike the model, like standard language model going left to right, remember like this is non-recurrent. So actually like for each input, so say like I read the book again, yeah. So for I, we encode the embedding of word I, but we also encode the position, that word I is in position 0. So in this case, like we can do this in parallel, because each input embedding basically already encode the position. So we can process, for example, attention forward from word 0 and from the last word together at the same time. if that makes sense, because we know the position. While before, like if we use RNN, for example, we need to go from 0 up to current word before predicting the next word. So in this case, yeah, we need to wait until we are in the current position to see all the previous word. But the idea of transformer model here is like we can see all the input because the input itself already encode the position. So
But
if you if you imagine like I have word I have the word embedding for word I have the positional embedding as well. So like position 0, this is the embedding or the encoding. And then you have basically two embeddings, and then you can concatenate them, or you can have dot product or something like that.
Oh, but is it possible also to get 2 words as a prediction from the slide number 17? Is it possible to have more difficult at same time, or we should choose more first and then the next process we get the difficult?
So this basically I think computed at the same time. So I think, yeah, so this is from the multi-head attention here. So yeah, I think this looks like a bit complicated, but multi-head attention basically this one neural network component that computes attention between each word here. So for making, we compute attention with all the previous words, all the words in the input basically. So making, so we also compute attention between making and it, for example. But I think like they don't really show this in this example. But basically for each word, so you can think about this as like this is lower level, this is higher level. And then for each word, we compute attention between this word and all other words in the input sentence. Okay. And then that is only one multi-head attentions, but you can have like 10 or hundreds of attention. And what they show here is some attention model learn different things than the other attention model. So when they analyze this, so for example, yeah, maybe this is not a good example. Let me, I think, like for example, yeah, I think this different color is basically different attention. How to explain this? So okay, let's take like making and difficult. So you see here like there are multiple colors here, like blue, white, green. So each color here is like one attention. So maybe like all this attention had learn the same thing, what is about making basically, and then they learn that this is like quite relevant to the word making, so difficult. But there is another attention which is big here, so we don't see in the difficult. So this is another attention that store basically the time. So maybe like this attention head tracking if there is like temporal information, time information about this event. I don't know whether that's clear or not.
Yeah, I guess
so basically
every color has its own attention. Do you think? Do you think
so
so?
I
Yeah.
think so. Say I don't know how many of this. Say like there are 20 colors here, so that means we have 20 multi-head attention.
Oh.
And each multi-head attention can learn or store different things. Maybe one store the object, one store the subject, one store the tenses, for example. Maybe multiple head attention store the same thing, like here, difficult. Yeah.
Can we see the legend of the color perhaps so we can?
Oh, I think, no, I think they don't have it in the paper.
Yeah.
Yeah.
Okay.
But the basic idea is that, like, I think there are some attention that tracking the, yeah, I think there are some papers that learn like what this attention actually learn.
Okay.
And then they said, like, yeah, some can track, for example, the punctuation. So attend like whether this is part of this sub sentence or the next sub sentence, for example. So there are multi-head attention that track the punctuation, for example. There are multi-head attention that track the pronouns. So for example, if you look at this, like what this basically refers to, and then I think they showed that sometimes like the attention can attend, like his or her, they will attend to the name that the pronoun refers to.
But in here, making also producing attention with the color of gray. Does it make sense that making can be part with another word itself?
Yeah, I think, I mean, like,
Is it
because this is
error?
like, no, I think because this is like, sometimes people just like analysis by checking manually the examples, and then the choices of like how many multi-head attentions we use is like quite random sometimes. So I think like people can sometimes see, oh, there are these attentions that you can interpret what they are learning, but there are some other multi-head attention that you don't know what they actually like learn. So yeah, I think it's
like
not
a black
always.
box.
Yeah, yes, it's not always
Yeah.
interpretable.
Yeah, we have Professor Adi Wibowo here. Have you, Satria, have you make Professor Adi Wibowo as a
Oh
co-host?
yeah.
So
I
you can
remember. Hello, Mas.
unmute his microphone. Please, Professor.
How come my name come to Professor Mr. Hello,
It's a
Clara.
prayer.
Hello.
Amin. Maybe actually I don't want to have a question. I just want to say happy your wedding. Congratulations your wedding.
Thank you.
Long.
Yeah.
It's Indonesian.
Baik kabar.
It's like a reunion.
No. Yeah, I think 10 years ago, I guess. Yeah, no, 12. Yeah, we met last time 11 years ago.
Yeah.
So actually, this is maybe how many? 3 times Mr. Fajar as moderator for Amazon person actually, and
Okay.
and the second Amazon, the both previous Amazon person actually when present about the technology in Alexa, they didn't how to say told about the what the architecture they use in Alexa and just about the the product actually. So
Okay.
so I think it's yeah, I think my question actually was to ask what the behind of the Alexa actually with the architecture or some technology that use, because I don't know, maybe I missed something about the Alexa in your slide.
Right.
I'm not sure there is
Right.
thing presentation about Alexa. So what kind of technology or architecture? This is my question because and the second one is actually usually when we use the
drop.
Yeah, the connection is unstable.
Oh.
time.
It's,
Yeah, it's
oh yeah.
Yeah,
I think
it depends
yeah
on the yeah.
we missed you a bit. What was the second question?
About the training time. So how usually come people like with low resources. I'm sorry, there is a noise.
It's
Usually, wait. So like how to say decrease the computation, like you mentioned about the how to say kind of
deployment.
Yeah, the like
Okay.
the how the use, like usually in image it's usually like point-based architecture and point-based convolution and so on, but how about in maybe a bird or in transformer, how to because how to improve the how to decrease the parameters so the can improve the training model, training times actually. And so this is like when I compare between 1D CNN compared to LSTM, the time training is totally very large difference. So it's for sometime when I usually use the NLP model for my time series model, not for the text, because text Dr. Ratno feel, so my bread will be not good enough in NLP. And this is the second one, and the third one actually I interesting about a kind of graph model. Actually, I'm not sure there is graph model in your presentation. There is any like recently graph model for the NLP, and also continual learning, for example, for incremental task learning or incremental classification or somehow like that. I think yeah. Thank you. Sorry for my question, because I just want to get a good question for your meeting actually.
Okay, thank you. Yeah. So for the first question, the back end for Alexa, for example. Yeah, maybe like I also cannot say it in detail, but essentially I think like the backend components is similar, like across even like Alexa, Google Home, or like other personal assistants. So basically like we have speech recognition system, we have natural language understanding components. So speech recognition system basically transform speech into text, and the natural language understanding transform the text, which is so basically like the natural language understanding component is transforming the question into text. And this part is actually a bit big. So first we need to understand like what the user asks about, like the intention, for example, and then map it to like some meaning representation. So yeah, it's kind of similar to SQL query, I guess. And then using this SQL query. So for example, if we want to ask who is the president of Indonesia, so the user will ask like in natural language. So we need to transform it somehow in a particular language so that we can query it into our knowledge base. So this is like the dialogue management system. So yeah, because there are multiple kinds of questions, I would say like it can be like there can be questions relevant to factual knowledge, like president, or like Jakarta, the capital city of Indonesia, for example. So that's kind of like factual knowledge. You would need like a knowledge base. And for that one, like you can use like some graph algorithm, for example, but basically like we also have this kind of knowledge base. So given this query, you then like fit this query into knowledge base to get the answer. So if the question is like, what is the capital of Indonesia? You try to find it in knowledge base return Jakarta. So we have this Jakarta, and then the natural language generation component basically responsible to transform, because we don't want to just output Jakarta, but we want to like communicate naturally with the user, right? So we need to say like, oh, the capital city of Indonesia is Jakarta, for example, and this is still on text level. So we need to return it to speech. So there's like text to speech component there. Yeah, but yeah, behind like each of these box, basically like huge like system. Because like depending on what type of questions you ask, like if it's a factual knowledge related question, you want to look into like knowledge base. If it's just like simple, say you want to ask the assistant to say what is the weather, for example, like you don't need like knowledge base. Basically, you can have a system to identify, oh, this is like this question is intended for weather report, so you can just like directly yeah, maybe select like the component that handle report, for example, and then return the weather, for example. Yeah, so I think, yeah, the dialogue management basically like is responsible for that, like what is the intention of the query, and then based on this intention, like you can forward it to like specific service that can handle that query, basically. Does that answer the question? Yeah.
I think
and
still do not mention about architecture or some model which you
architecture. So depends, because
depends.
Yeah, because it's kind of a big organization. So there are teams that handles knowledge base. There are teams that handles the parsing, for example, like parse the natural language into. So it's very depends on the which team like responsible for what. So for example, maybe I can tell a little bit like the semantic parsing model, for example. I think we already like use, again, like there are multiple teams also doing this, because like it depends on like which query using, which questions and for which intention. So yeah, I think at least like some of the models already use like pre-trained model like BERT. Sometimes, some models I think we train ourselves, but some models we also use like just the available pre-trained model. And so what I'm working on at the moment is mostly for the knowledge base population. So basically like extracting facts. So basically like identifying entity and then perform relation extraction, and then get the triple, which is just like the first entity relation second entity, and then put this in a knowledge graph. So for that one, basically like, there are multiple architectures that we use. I think mostly we try to follow up like the state-of-the-art architecture that is still doable in terms of deployment. So there is like trade-offs between this. Like we want to have good model that achieve state-of-the-art, but at the same time we also, I think because this is like also very related to product, like we also want to have something that is deployable, I would say. Yeah, so it's a trade-off. Like sometimes like we can sacrifice a bit of performance if we can deploy it better. And then in terms of inference time, I think the most important one is inference time, because like you don't want to answer questions very long time. You need to like answer right away. So latency is like very important there. So yeah, I think so for example, I think we don't really use like the big GPT model or the big I think yes, we still use Roberta, I think. I think sometimes we try to experiment with other newer models. So for example, for NLP, the Berta, I think they call it the Berta model. I think this is from Microsoft. So they have like several models, base, large, X large. Yeah, so I think we usually, the way we work, we usually like we try experimenting with them, computing the latency, and then see the performance, and then make a decision based on that. Yeah, I think, yeah. Is that answering the first and second question?
Yeah. Oh, okay. Yeah, of course. Yeah, the second question, yeah, answered. So like, okay, good, nice. So we should be thinking about the deployment, yeah, about the time.
Yeah. So it's not always like you need to have a good work. Also, like in real case, maybe a bit different with academic world, like we always like measure performance based on like standard benchmark data set, and it's not always the case that it will perform well on like the real data set that we are working on. So yeah, I think there's also, so sometimes like there are like big difference between using like larger model versus small model on this benchmark data set. But when you work on like specific data set, like specific domain, for example, it can be like maybe not that different that much. So you can still use like the smaller model.
So the lightweight.
Yeah. I think that's again.
There's a delay.
Main like there is any kind of threshold, so we should use this performance. So like should be like, for example, 90%, for example, maybe for accuracy, or for other things, maybe like, so there is any like threshold for performance?
Yeah, there is like, I mean, because we don't want to output like, for example, in my case, we don't want to output like wrong facts, like we don't to like answer wrong answer, because if we answer like lots of wrong answer, it will be like bad for especially like for like popular people. So in that case, we need to set threshold. So usually like whenever we deploy a model, we need to evaluate first, like basically annotate a sample and then measure the performance. And then if we are happy with like some threshold, which usually quite high, 80 or 90%, if we are happy with the quality, like then we can move it into production or something like that.
Okay.
Yeah.
Thank you.
And then, for graph learning, yes, to be honest, I'm not an expert on this. But I think we ourselves like don't really use like graph algorithm at the moment, because sometimes it's a bit expensive, especially if you work on like large knowledge graph. But I think in NLP, like some people also use graph, for example, I think depends on like the purpose. For us, for example, it's like for the knowledge graph itself. So so knowledge graph basically like the nodes are entity like Joko Widodo, and then relation is like president or live in, something like that. So if you have large knowledge graph, basically like I think some groups use graph algorithm to embed the entity or relation, and then use basically those embeddings to perform relation extraction or entity disambiguation, because sometimes entity disambiguation is also hard. Like if you have like multiple names with Joko Widodo, if you use machine learning model, like the model will, because we need to link it to the right Joko Widodo, which is not president, for example. But if you train it using machine learning model, it will always predict the most popular one that is occurred in the text, which is the president. So that's one example of the problem. So I think that one. Continual learning, I think there are somewhat in curriculum learning. I think there are multiple direction. One that I'm a bit familiar is like there is like one direction in NLP which identify which examples in the data set is hard and difficult. So you can identify it based on, for example, the confidence score for each model. So for example, if the model is not confident when predicting this, maybe that example is hard. There are also like ways which you measure, you predict the example using several models. And then if the model agree, maybe like the example is easy, but the model doesn't agree, maybe the example is hard. So I think the one that I know is like, yeah, they try to analyze the training data. And then during training, basically you perform curriculum learning. So you train the model using easier example first, and gradually like you feed them with like more difficult examples. So you play around with the order of the batch during training, basically. Yeah, but I think like there are also other ways. For example, if you keep doing annotation and then you want to continue learning from like recent annotation, you can like do some fine tuning, but somehow set it up so that the model won't forget like the earlier fine tuning data. So in that case, yeah, you can freeze a bit some parts of the model so that it won't forget like the older fine tuning data, and then only update like some layers or like change the rotation when you update the parameters. So yeah, I think there are something like that, I think.
I see. So the confidence. Okay.
We have another
oh yeah. Okay.
raised hand over here. Can we give him opportunity for this moment?
Yeah, yeah, of course.
Okay.
Thank you,
Thank
Clara,
you.
for very nice.
Yeah.
We have Mr. Yoga. Can you unmute yourself?
Ya,
Go on.
maaf saya menggunakan bahasa Indonesia ya.
Iya, nggak apa-apa.
Dan pertanyaan saya ini agak melenceng dari topik yang materi yang dibahas sekarang ini, tapi masih dalam area NLP. Saat ini saya riset tentang teks menggunakan algoritma LDA, Latent Direct Allocation. Kalau saya membandingkan dari algoritma yang tadi itu, kalau saya melihat kok nggak ada data yang dibersihkan gitu, artinya bahwa data-data itu utuh apa adanya lalu digunakan. Sementara yang di LDA itu saya melihat dan saya lakukan banyak sekali data yang harus saya bersihkan, saya beneri, saya hilangkan begitu, sehingga data itu baik. Gitu. Nah, lalu proses selanjutnya adalah dalam proses LDA itu membentuk sebuah cluster topik yang harapannya bisa kami prediksi. Nah, dalam proses prediksi ini saya yang masih ragu gitu. Cluster ini siapa yang harus memprediksi gitu? Siapa yang harus menerjemahkan topik ini sehingga kelompok topik ini itu tepat gitu. Bahwa maknanya dari cluster ini adalah A atau maknanya dari cluster ini adalah B. Nah, ini kira-kira Bu Clara bisa memberikan insight untuk penelitian saya ini.
Maaf Pak Yoga ya? Dari program DSI.
Iya Pak.
Oh iya.
Terima kasih.
Silakan Bu Clara.
Iya, kalau setahu saya LDA itu buat klasifikasi topik, tapi kita nggak tahu ada berapa topik di dokumen ya. Jadi itu kayak mungkin lebih ke unsupervised topic classification karena ya saya lupa sih, tapi seingat saya sih kita harus pertama define kan kira-kira ada berapa topik, jadi itu kayak jadi parameter dan modelnya nanti akan mencoba cluster dokumennya ke topik, ke n topik, di mana n itu yang kita yang define. Iya, jadi yang saya jelasin sebelumnya kebanyakan itu lebih ke supervised topic classification. Jadi kita udah tahu ada berapa topik di sana. Jadi kalau unsupervised text classification itu karena ya unsupervised biasanya jauh lebih sulit sih untuk tahu topik-topiknya. Tapi ya setahu saya sih ya mau memakai metode apapun ya, misalkan mau pakai LDA atau mau pakai metode yang neural network based, ini perbedaannya mungkin di tahap evaluasi ya. Jadi mungkin evaluasi agak berbeda. Kalau misalkan supervise, kita evaluasinya berdasarkan angka performance. Tapi untuk kasus unsupervised clustering, mungkin ya kayak sepertinya sih, ya saya juga nggak terlalu banyak pengalaman di sini, tapi sepertinya ada dua cara ya. Yang pertama mungkin untuk LDA, contohnya mungkin sebagian besar kita pertama harus define ini kira-kira ada berapa topik, terus karena itu jadi parameter, pada akhirnya kita manual harus cek apakah topik-topik yang terbentuk itu masuk akal atau enggak. Dan biasanya ya saya nggak tahu sih apakah ini masih up to date, tapi biasanya kita lihat misalkan kata-kata keywords yang menggambarkan cluster topik tersebut itu keywords apa aja, terus dari situ kira-kira masuk akal nggak. Jadi tetap butuh, ya kalau ada budget mungkin butuh anotasi sih untuk tahu apakah topik-topiknya masuk akal atau enggak. Yang kedua mungkin mungkin ini agak berbeda topik, jadi bukan pakai LDA ya, tapi ada juga yang intinya kita nggak define dulu jumlah klasternya berapa, tapi pertama step yang pertama mungkin kita cari misalkan representasi dari teksnya atau dokumennya, lalu dari sana kita coba cluster sampai ya mungkin pertamanya misalkan kita secara random pilih beberapa sampel dokumen atau teks, terus kita jadikan representasi dari setiap cluster, jadi centroidnya. Lalu habis itu secara iteratif kayak kita bikin klasternya itu lebih konsisten. Jadi iteratif itu kita cek berdasarkan biasanya distance dari representasi dari dokumennya ke centroidnya, terus kita update lagi centroidnya. Ya jadi lebih kayak nearest neighbor kali ya, algoritma ya. Iya, kayaknya itu sih yang saya tahu. Nggak tahu membantu apa enggak ya.
Bagaimana Pak Yoga? Apakah masih ada pertanyaan lanjutan? Halo Pak Yoga. Oh ya, cukup.
Iya.
So I still opening this question answering session for our students, especially our machine learning subject. Come on.
I think too hard for
Huh?
students. I think too hard for a student from machine learning.
How about Dr. Ratno? Do you still have another question?
I think I can speak by private chat with Clara if I have a question, because I'm afraid it will make the student intimidating.
Yeah, even more. Okay, we all.
If there are
Yeah.
other questions, feel free to email me. Yeah.
Oh yeah. Have you shared your email address, Doctor?
Yeah,
Was
I
it
think
in
on the
the
slide there is
slide?
my homepage. So there is
The
in
first
my
page?
homepage. Yeah, first page
Oh
there is
yeah, your
link.
GitHub.
Yeah, yeah. It's
And
a homepage link, so there is my email link.
claravania.github.io, isn't it?
Yeah, yeah.
Oh, okay. So for all students or every attendance here, you can always contact our speaker via her GitHub profile. So we already passed our time session. Actually, it's already 15:16.
I have a question, Pak
Oh,
Fajar. Saya mau nanya pakai bahasa Indonesia aja deh, pakai bahasa Indonesia. Kenapa dulu ambil S2 lagi, Clara? Kan sudah S2. Terus kenapa ke UK S2 lagi? Karena pengen lama-lama di UK atau gimana sih sebenarnya?
Aduh, karena mungkin merasa belum mantap ya masalah machine
Clara aja
learning-nya.
belum mantap, apalagi saya.
Enggak lah, beda.
itu bukan permintaan dari supervisor, Bu. Soalnya teman saya ada yang digituin sama supervisornya. Disuruh master
Enggak
lagi.
sih.
Oh ya, itu Ibu sendiri.
Dulu emang apply-nya programnya langsung master sama Ph.D. Itu satu program. Jadi,
soalnya kan beasiswanya jadi
iya.
kepotong kan ya.
Iya.
Terus tahun kelima bagaimana tuh, Bu? Bagaimana survive dengan
Oh, saya dapat ini sih dari supervisor.
dari internal ya. Oh, jadi
Iya.
kayak switch funding gitu ya.
Iya.
Saya
Itu
insya Allah tahun depan, Bu.
gimana, Pak Clara?
LPDP.
Bu Clara. Mungkin
Kenapa?
buat teman-teman S1 ini kan pengen misalkan S2 ke UK gitu, kira-kira saran tripsnya gitu.
Mungkin tipsnya, jadi S2 kalau iya mungkin tergantung ya tertariknya di bidang apa. Jadi mungkin pertama cek dulu universitasnya kira-kira bagus nggak di bidang tersebut, karena beda-beda kan ya. Jadi jangan cuma cari ranking universitasnya sih, menurut saya cari juga mungkin di sana ada profesor yang bagus nggak untuk bidang yang tertarik gitu. Terus kalau di UK itu S2 cukup singkat banget ya, cuma 1 tahun, jadi lumayan padat sih. Kadang-kadang bisa bikin stres sih. Jadi iya, jadi itu satu sih. Jadi S2-nya singkat banget. Bahkan kalau misalkan mau ke Cambridge atau Oxford itu kayak S2-nya cuma 9 bulan. Jadi itu kayak padat banget. Kalau mau lebih lama, ya mungkin ya tergantung ya preference-nya. Kalau mau cepet ya bisa ke UK. Kalau mau lebih lama, misalkan mau punya pengalaman internship di mana di research lab atau di industri, itu mungkin lebih relax ke Eropa atau ke Europe. Saya lupa, Jepang 2 tahun apa 1 tahun ya? 2 tahun kali ya. Ya pokoknya beberapa negara yang lebih dari 1 tahun itu mungkin agak lebih relax kalau mau punya experience lebih ya, karena waktu studinya lebih lama. Jadi ya tergantung preference masing-masing. Ya tapi lagi-lagi kalau misalkan tertariknya ke arah riset, terus planning buat S3 studi lanjut, kayaknya ya cukup penting untuk riset pertama ya yang ditargetin universitasnya itu risetnya gimana. Misalkan tertarik NLP, misalkan tertarik core machine learning, misalkan tertarik computer vision, itu di universitasnya ada profesor apa enggak. Jadi ada potensi buat ikut research group mereka atau enggak gitu. Jadi karena itu nanti juga penting ketika mau apply S3 kan, kayak pengalaman riset sebelumnya gimana gitu. Biasanya ya apalagi sekarang ya deep learning semua orang publish-nya udah gila-gilaan mungkin dibandingkan tahun kita S2 itu udah jauh banget sih sekarang, kayaknya jauh-jauh lebih kompetitif. Jadi jadi kalau misalnya juga masih mikir-mikir nanti mau S3 atau enggak, kayaknya ya S2 kayak coba, mungkin saran saya kalau tertarik ke riset, coba dari tahun S2 itu coba approach profesor yang melakukan riset gitu, gimana bisa nggak kayak join riset group yang entah bantu PhD student atau gimana gitu. Iya, itu sih mungkin.
Itu dari kita kan membangun relasi dengan profesor dulu ya Bu
Iya,
ya.
iya.
Itu Bu Clara tuh langsung first shot dapat apa dari sekian attempt baru dapat yang itu?
Untuk PhD saya
Ya, untuk membangun hubungan dengan
nggak langsung
profesornya itu.
dapat sih. Jadi dulu pas tahun saya master tuh kan ada master project ya. Jadi kita harus kerja kayak research project sama profesor. Jadi di situ biasanya sih, jadi yang saya lakukan dulu sih kayak ya email beberapa profesor yang saya tertarik kerjanya. Terus biasanya mereka bakal ngundang untuk diskusi, nggak lama sih, paling setengah jam maksimum. Terus biasanya tergantung kalau risetnya align atau mereka masih bisa supervise, mereka bisa mereka bisa ambil kita jadi studentnya gitu. Tapi pokoknya mungkin ya ketika udah S2 atau misalkan nanti udah, ya kalau ada beberapa yang S3 sih, saya sih coba segala macam opportunity ya sebanyak-banyaknya, karena itu kayak mungkin waktu yang paling baik untuk nambah experience, entah kalau mau ke akademia jadi profesor, coba visit research lab atau coba apply internship. Jadi ya kayaknya itu ya kesempatan yang baik sih menurut saya. Terus mungkin nggak usah terlalu takut untuk kontak profesor, walaupun mereka udah terkenal ya. Maksudnya ya saya dulu juga pernah internship, jadi saya juga nggak kenal profesornya, tapi cuman saya email aja ke mereka, misalkan ya jelasin riset kita ini, kita tertarik dengan riset mereka. Ya kebanyakan sih sepengalaman saya baik-baik ya, maksudnya mereka akan reply. Bahkan saya buat postdoc kemarin juga, saya juga nggak tahu, maksudnya in person saya nggak gitu kenal gitu, tapi ya kontak aja, maksudnya email aja. Biasanya sih ya kalau mereka butuh PhD student atau mereka butuh postdoc atau research student, bahkan pas master mereka bakal reply sih. Kalau nggak di reply ya udah nggak usah sakit hati, tapi maksudnya nggak usah malu-malu untuk approach mereka duluan gitu.
Jadi kalau nggak ada balasan berarti memang nggak cocok gitu aja ya Bu ya. Langsung cari yang
Iya,
lain.
belum tentu juga sih, karena kan mereka sibuk sekali ya, jadi mungkin coba follow up lagi kalau udah seminggu 2 minggu nggak dibales ya. Kalau udah 2 kali nggak dibales ya udah mungkin cari yang lain. Iya. Soalnya orang luar kadang-kadang juga punya, kalau liburan agak lama kan, bisa 2-3 minggu dan mereka nggak cek email. Jadi kadang-kadang ya mesti di follow up sih.
Bu Clara PK berapa Bu kemarin Bu?
Udah jauh banget saya, 11 ya.
Bu 11.
Iya.
Saya 194.
Oke.
Banget. Baik, Bu Retno bisa ditutup apa mau lanjut lagi?
Untuk kasihan Clara.
Mau kerja ya Bu ya?
Oh udah weekend.
Oh ini weekend, iya. Okay, Dr.
Okay.
Vania, on behalf of our department, we would like to express our deep gratitude. Hopefully we can have a future collaboration. Everything starts from we can start something from here, hopefully.
Okay.
Uh,
Yeah.
So I think I've done my job. So I will return this session to our Master of Ceremony, Vicky.
Thank you.
Thank you, sir. Is it clear? My voice? Okay.
Yeah.
I should start then. Thank you, Ms. Clara Vania, Ph.D., for your enlightening lecture and for sharing your experience. And also thank you, Mr. Fajar Agung Nugroho, ESCOM MCS, for guiding the session, which is very interesting because a lot of experts as to Dr. Clara, yeah. A lot of students as it. And ladies and gentlemen, we are now coming to the end of this event. We deeply apologize for any inconvenience that may occur during this event. We hope that all of us can learn a lot from today's session. Thank you for your participation and see you in the next event.
Bye, Dr. Clara. Thank you very much.
Terima kasih, Clara.
Thank you.
Thank you.